Miller and Chitty Boiler Service. We are the New Jersey rep for Cleaver Brooks, a couple other brands, boilers. I've been working with Miller and Chitty 30 years this October, so I've done this before. You guys have two new Cleaver Brooks fire tube boilers to match the one that you had here. I don't know if that's the same one, but they're CBI's 200s, which is dual fuel, 2 oil and natural gas, 300 horsepower fire tubes. These are hot water units. 125-pound working pressure shell. I don't know what you run at. You probably don't need that kind of pressure. Only 2-story.
Cold water heaters.
Cold water heaters right now. They're only cold water.
They're cold water.
Can I use them for now?
No.
No.
Heat hot water. You heat cold water.
Yeah. Oh, okay. It's going to be all day with these little.
You never know.
All right. Like I said, fire tube boilers. Number 2 oil, natural gas. What you guys have here, because I guess New York City you have auto changeover. I'll get into that later, but you see that you have the gun outside temperature. When they tell you to switch over to oil, it's going to automatically do it. You're not going to have to do it the way they designed the circuitry on these boilers. Also, these boilers, they're what they call a low NOx boilers, 30 part per million or below. Usually run around 25, 26 part per million. The way they do that, they have what's called FGR, flue gas recirculation. What they're doing, through an internal damper, they're taking part of the exhaust gas, the combustion, the emissions of the boiler, and they're bringing it back around into the flame zone through an internal damper, through the burner. And what that does, it cools the flame down without adding any extra oxygen to it. And by doing that, it creates or stops or retards the slowing of the nitrogen and the oxygen from making NOx. That's how you're able to get it. Get emission people, EPA, they want you to get boilers that don't have FGR and try to get your NOx levels down. It's almost impossible. When you have the heat and the nitrogen and the oxygen in that flame zone with that temperature, it creates NOx. We don't do it as much with 2 oil, even though it can be possible. One way to reduce the NOx levels on a 2 oil, they get lower special flue, I guess low nitrogen 2 oil, and that helps reduce it too. I don't know what kind of levels of NOx that are on this burner. Like I said, you'll probably be around 25, maybe 24 on gas, and you can be anywhere like in the 50 to 70 range with 2 oil. Usually, since it's your secondary fuel, it's not as imperative since you don't really run it for the majority of the time. You get by with having your air permits on it. This boiler, everything is contained in the front head of the boiler. You have a separate burner right here that's mounted inside this front head. By releasing all these bolts around the perimeter of the front head, and then you have to pull the burner, this outer ring. Inside there are internal clips. They kind of look like clips that you would have seen on the old boilers like Kiwanis and Burnhams, how they used to close the doors. All they are is a piece of flat stock that's bent at an angle. Whatever you do, don't pull this burner and pull this ring and these bolts and think you're going to get this door open. We've seen contractors on startups where they actually had to remove a door to get it into a boiler room, and they've cracked the head. One company tried to use a forklift with a pin bar to pull it back, and they actually split the head. Joke you not. St. Barnabas Hospital. First time I went to open 200 horse, I almost did the same thing. I bent my pin bar and I said, there's something wrong here. But we'll get into that later. They say it's a number 2 oil and a gas-fired boiler. You have natural gas lines coming in. This is your main gas line. You have a separate one that's on the side. It's your pilot line. You got a double block, 2 normally closed solenoids, and a pilot regulator that brings down the gas to what's normal going into the burner, which is usually about 4 inches. That's why this valve is here. That valve is there. You can adjust it to get back pressure going into the burner. Sometimes with some boilers, depending on the draft, we want to choke that back so we have a good 4 inches, 5 inches of gas going into that pilot assembly. If you don't cock it back, there's really no way you can open up that regulator all the way you want. And without a little bit of back pressure, all you're going to do is make the pilot really rich and it's going to soot up. The gas train are Siemens gas valves. You can see there's no main regulator on this valve, or on this gas train. Normally you would have a Maxi-Trol or a Siemens or some other main regulator coming in, dropping it down. Siemens here, they use it all in one total package unit. This is a gas valve with 2 seats in it. It's a double valve. Your first actuator is just a normally open-close actuator. The second actuator actually has a regulator built into it. What it's doing is sensing the downstream pressure through this sensing line. The boiler fires off, and that sensing line and this regulator maintain a steady pressure going into the burner upstream and downstream of that butterfly valve. It's amazing how good they track on with that. They're pretty much dead on. You'll have a little bit higher in low fire, but things are amazing. They have little indicator lights on them showing where their positions are with indicator levels. Normally when these boilers are firing, that first valve, since it's an on-off boiler or on-off valve, it'll be wide open. The second valve is going to be open proportionally to maintain that downstream pressure. Those indicator little levers on there give you a good idea if you start having problems on it, because instead of getting the meter out, you'll have a light showing that you have power to it, but if you don't see those indicators in the proper position, what you normally see, we're going to shut this down. Can we get by?
Shut down the third one
Yeah,
because it's
'cause
going to
gonna
recognize
start
it.
on.
That one's
might
already
be
off.
Good for me to jump in a little bit. For those of you, I'll introduce myself real quick. Eric from Miller Proctor. Nicholas out of New York. The Cleaver Brooks reps on the other side of the bridge there. We were working with the design team to choose these boilers and get them in here. Everything that he was mentioning on this gas train, we actually, the only real change that we made to this original, so we mentioned at first, we provided 2 additional boilers to complement your one original. Also part of that scope was to upgrade the gas train that was on this one to match the other 2. So part of this was to swap out your whole gas train on that side, all those mechanisms that he was just talking about, first valve, second valve, double body, all that stuff, is now on this boiler. So that's really the only change on this boiler, any real substantial change, I should say, that was made to this boiler during this whole upgrade process. Just wanted to point that you can jump back in. I just wanted to make sure that they knew that everything that he was just talking about also was thrown in on this other boiler.
All right, like I said, so that's included your just 2 gas valves, positive shut-off. You don't have what's called a block and bleed, an IRI train on here. That would be 2 normally closed valves and a normally open in between. This is an FM train, just 2 closed valves. Also mounted on here, part of the sensing line, you have a Honeywell switch, which is a high gas pressure switch, manual reset. In case that regulator failed and it allowed your full line pressure coming in, you would exceed the setting of that, it would trip, and it most likely would show up on your Hawk screen, which I will get into later. Yes, almost every control on this boiler, safety and limit control, has a 3-wire wiring schematic. This way, what it does, if it's not in its normal position, it sends a, uh-oh, I got something wrong with me, signal back to the Allen Bradley, the Hawk processor. So it's gonna, I call it idiot switches. It's gonna tell you right where the problem is. Oh, you got a problem with your low gas, you got a problem with your high gas, your low water. Everything is first out enunciation, and it tells you where the problem is. Makes troubleshooting, and even for calling for service. Hey, this is my problem. Gives the service tech maybe an idea of what to bring and what he needs on the job. You have a low gas pressure switch before it, same thing. For some reason, the line pressure, somebody left the valve shut off, something happened upstream, you drop below the safety parameters, it's going to shut the boiler down and it's going to give you a warning on there. That's your natural gas. Downstream, this boiler is what's called parallel positioning. Instead of having linkage and cams, and we have what's called servo motors. There are 4 servo motors that are being controlled by that same Allen Bradley processor, the Hawk. So, you have 4. You have your air, which is attached to a rotary damper on the burner. You have your gas, which is on the gas train, which controls the input of fuel, natural gas into the boiler. You have your oil servo, which controls the amount of oil to match the air with the firing oil. And then on both fuels, you have an FGR servo, which controls that FGR damper. When you're firing oil, you have a bunch of components that are on there. This boiler fires 2 oil, like I said earlier, and what it does, instead of being a mechanical atomization like you would use on your home burners if anybody has oil at home, they're getting that oil into a fine mist into the burner zone through compressed air. You have an air compressor mounted on the side of the boiler. All it is an air pump. It's got a motor, cooling coil, cooling fan to keep the lube oil, which lubricates that compressor.
I need to get one of these spoilers on when the pumps are going to go next.
All right, no problem. All right, you got it.
I have to go reset the alarms downstairs.
All right, we'll take a break. Shouting over the boilers. Scanner, which you've probably seen before, it's an infrared scanner. What that's doing, you got 2 different types of scanner, infrared and ultraviolet. That's 2 lights at either end of the spectrum you can't see. This one's infrared. So it's looking at all the infrared energy that's in that flame, sees it. Once it says it's above a threshold, it opens up the main fuel. And once you're good, lets it establish main fuel, then goes to run. It's going to run that boiler and increase the modulation to match to what you want in your system. You can see on your screen on the side where you are in your firing rate.
Ask him.
What's that?
He has a question.
Why does compressor not need water?
When we're in fuel oil, he's saying that the air compressor.
The lube oil?
Yes.
I used to be in Brooklyn.
Yeah.
The only thing I was in had a boiler from a Star Industrial. They never put in, maybe every 6 months I might look at this water.
Well, if you look at these tanks on the side over here,
Take a walk over. See what
there's
it's
a
like.
rubber plate. And all it is 2 pieces of like diamond plate, like chicken wire. There's probably 4 stainless steel pads in there. What's happening? You're getting carryover. You take this plate off, it slides out, and all it is like 2 stamped diamond chicken wire kind of things with a rod between it. They take bronze wool and they just put it in there and they shove it back in. So as the compressed air and lube oil from the compressor is coming into this chamber, you're trying to catch as much of that lube oil as possible and then let it percolate down back into the reservoir. What's happening, you're short cycling that, and it's just going into the burner. So, my opinion, it's not a bad thing. You're not paying for the lube oil. I would rather you keep adding nice, clean lube oil into this tank, into this thing, and just let it get carried over and burned into it. One thing, and I hope you're aware of it, don't ever add oil into this air compressor without the air compressor running. Very critical. You pour oil into this air compressor, and I hope everybody hears that. You pour oil into this with it off, and then you go to start up this air compressor, you'll damage it. These air compressors, you ever remember the old Mazda rotary engines where you had, what it is, it's almost the same principle. It's just like any air compressor. It has a lobe and it has graphite fins in it. That as that lobe turns around on the shaft, those fins slide out, catch the air, and then compress, and then throw the compression out. You put oil underneath this, and now that oil is going to be sitting in a chamber, stagnant. Now you go to start it up, you're going to compress that oil, and oil liquid can't compress. What it does, it snaps off one of them fins. Once that fin snaps off, it ruins all the other fins, and you're done.
The off-cycle, can't you fill it through?
You can fill it in there, not in here.
This is running, this is not running.
I recommend just to do it when you're running, putting it in there. Trust me, I did it myself. I mean, it was like probably 25 years ago, I rebuilt one and I said, let me pour a little oil in there so I don't start it dry. I started up and I had no output. My foreman at the time said, come back and get a new pump.
That easy.
That easy.
What happened? Just come get a new one.
And also too, nice clean oil. Don't take oil, keep it in a jar, dust, contaminants. You know, we sell this oil that we use, Grouper Plate, 20 non-detergent. Use them straight out of the quart, nice and clean, pour them in there. Also, you want to have an oil bath inside this filter. There should be one in here. There is. You see there's a little bit of oil in this cup. That keeps any air or particulates from getting around that filter. You can always check that and clean that out every once in a while. Don't hurt, just to make sure. See how, if you ever see any pieces of rubber, you know, you got a Lovejoy coupling with an insert, start seeing some black over here, you know, there's something wrong with your motor and your pump got out of alignment, and it's eating away that insert. You know, address that problem, because you don't want it to get bad. Eventually you're going to lose the insert, and then you're going to lose the coupling, and then you could damage either the motor shaft or the pump. So, I don't know what the insert would cost. It's not going to be much. I'll find it. Can't get it. I'll get back to that. I don't waste time on it. So, you got your air compressor, and you have your oil pump. You have your oil lines coming in, supply and return in the boiler room. Then you have a secondary pump that's pumping the oil up the pressure going into the burner. Normally 70 to 80 pounds pressure coming into the side rail here. Then we have a reducing regulator that reduces it to an average of about 30 to 40 psi on 2 oil. Could be more, could be less, to get the rated amount of oil to match the air compressor air to get into the burner. Usually we use that pressure depending if we had an oil flow meter on here to get the rated input of the boiler. Since we don't have one on here, we pretty much do it by eye. You'll be in the ballpark. We know our air damper is almost 100%, and we get our fuel in there, we're down around the 3% O2 range. I know I'm pretty much in the ballpark with gallons per minute, just to match the 300 horsepower. A lot of people, my opinion, the best, they put a oil meter on the discharge going here into the burn. Some people will put them on the supply and return, but that makes you do math. That's not fun.
Well, actually, in your situation, part of the fuel oil installation was they put overall meters on the main fuel oil supply and main fuel oil return, so that on the BMS, this is all BMS equipment, but on the BMS they'll give you a total burn for the plant. It's not going to tell you each boiler, but it'll tell you total for the plant, which could subsequently be used for that, but that was all put in after.
That makes sense because the state just wants to know how much oil you're burning for the year. It's all with emissions. So once you come out of your fuel oil regulator, we drop our pressure down. Just like on the natural gas side, we have an oil servo that's metering the amount of oil that's going through the gun to match the air depending on your fire rate. When just like with the gas train, you have an oil train here that's got two ASCO solenoid valves. You have Siemens oil valves over there on that boiler, I believe they're Siemens, and you got the ASCO solenoids on here. It's just a different style, and they do the same thing. It's a little air gap in between.
Should a replacement be necessary? The ASCOs are what's available now rather than the Siemens?
Either or.
You can get either or.
Get either or.
Would you recommend replacing? They both serve the same function.
One thing with those valves, they actually have proof of closure. So
Where these don't.
where these don't.
So you need to change them in kind.
Yeah, and
Because I'd like to make all three the same if I could line it up.
right, and then you could probably, I'm not sure if you have one or two proof of closures on the electrical print on gas. I can look. But normally what they do, they run the proof of closures in series with all four valves, or sometimes they only use one gas and one oil valve, but that would be an easy modification to do. Especially having the changeover, it'd be nice to know, do I have a valve? You might not be running oil all, for 3, 4, 5, 6, 7 months, but I got a valve hung up in the open position. So
We know that.
we would know it, yeah.
We know it's the ASCO.
Right.
See, I want to get a spare solenoid.
You would
Valve doesn't go bad, the solenoid.
You would find that out when you were running on gas, not when you went to go to oil. Because it wouldn't allow the boiler to fire on either fuel if any one of those closures were open. That's the purpose. Also, this is a little air chamber that's in between valves. The reason it is, when you get two solenoids that close like this, or two valves that close like that, you get oil that's trapped in between them. That oil changes at ambient temperature, expands. And what Cleaver Rocks and other manufacturers have found, that causes the proof of closure switch, not this one because it's going to leak by and go right down, but this one will hang open. And then it's going to cause nuisance shutdown on that proof of closure that's open. They used to put a dump valve in between, and they went with this design.
That boiler has it.
That's got an hazard right there. See? What this is an adjustable pressure relief valve that goes back to the return to eliminate that possibility. Does the same purpose, just two different ways of engineering that they did it. So when you come out, your oil goes through, you're going into the gun, atomizing air, oil, they're going down separate pathways until they hit a nozzle. That nozzle puts the atomizing air and the oil together, the tip, sprays it into a fine mist, burns. Simple as that. Not much to it. A lot better design. The older versions used to have a small O-ring that separated that atomizing air and the oil, and it would give you headaches. That O-ring would wear out, the dry rot, it would cause the fire to pulse. It's amazing how like a nickel problem, little rubber O-ring would cause you so many issues with nuisance failures, especially in the low end, putting gaps of air, bubbles in the fuel, and dangerous. My 30 years, the worst incident I've ever saw was a 3-second gap in oil. At a job, I was working on one boiler while the other boiler was firing on oil. Actually blew the front head in a decent scene. Scary. And it was because of a 3-second gap in oil. Back in the olden days, they used to put, you have an atomizing air switch. This is a safety switch to make sure that you have enough compressed air. This is a safety switch to make sure you have enough oil pressure. They used to put those switches in the fuel valve circuit. Not allowed to do it anymore. Nothing can be in the fuel valve circuit. The job I was on, this was in the fuel valve circuit, and it had an air pump driven by a belt, so it was slipping. It shut the oil valves off for 3 seconds. 4 seconds it would have failed. Well, it went and introduced the fuel on the 4th second and it lit off. And it blew every single gasket out of the boiler, blew the front head into pieces, blew the stack off the boiler. Why, I was standing right there. I'm glad I wasn't working on that boiler that day. It was a little scary. But that's that. Because that's a hot water unit. You have the Hawk. You have the Hawk, which has an operating and a modulating set points in it, which is done through a temperature sensor. You have a temperature sensor that's mounted up near that hot water supply, which is, it's probably a resistor, and that's measuring the temperature of the water going out, going back to the PLC control. You have what's a set point, and that's programmable in your limits or your set point limits. Your on point, where you want to start the boiler, your modulating point, where you're trying to maintain your load, and then if even at the minimum firing rate, you're increasing the input to what the building needs, it's going to modulate down and eventually shut off at your off point. That's running on local. Each boiler is the same way. Downstream of that, in the limit circuit, you also have other controls. Most likely you have a high limit, which is a manual reset. That's a fail-safe in case something happens with the controls and the boiler doesn't shut off. If the temperature keeps increasing, that controller is going to trip. It's not going to allow the boiler to reset for once again until you go and reset it. Most likely that's wired with 3 wires again. It's going to come up on your alarm saying, hey, I just tripped my high limit temperature control. That's running on local. Now, you have what's called the master panel. The master panel is just a lead lag controller, sequencer, which controls all 3 boilers. All 3 boilers are controlled by that master panel. The master panel has a sensor, just like the boiler that's the one that's on the boilers, in the header, the main supply. What that does, it's going to call on 1, 2, 3 boilers as needed to maintain that set point depending on the various BTU loads of the building. It's going to sequence the boilers for the most efficiency depending on how it's set, and it also does a rotation, lead lag, depending on how it's programmed. We can get into that later also. A lot of things on the Allen Bradley, the Hawk controls. are safety parameters and they're set up the way that they're supposed to be set up for the boiler. Then other settings, temperatures and operating limits and stuff, not operating limits, but set points, that really depends on the building. I might be here once a year, twice a year. You guys are here 24/7. You always have a crew here. You have a better judge of what you need to be set. Sometimes things need to be tweaked. It might need to be tweaked summertime, wintertime. So getting in and playing with the numbers on here. That's one thing too. I don't know if you know passwords. There are like different levels of passwords. You can only get into with the ones that you should have is normally operator. I believe it's operator 3232. That lets you into like end user parameters. Right? Yeah. There's certain passwords that we don't give out because we don't want people to get in there and start messing with stuff. You can get into the startup screen and hit the wrong button, and there's what's called fuel curves, and you can lose those curves. We don't want to do that. Safety and limit controls. I said I went through that on the gas and the oil. You have your low oil pressure switch, your low ionizing air switch. You have a high limit switch over there. You have an oil draw switch. You guys have an oil changeover depending on outside temp. Now, if all of a sudden it dropped below, I don't know what the number is, 20 degrees. You know what the number is? It's in the teens. So, well, whatever the number is, if you got below that and it changed over to oil,
Say it's 5 degrees outside.
5 degrees. And if you don't have these guns in, making that switch, you're going to have 3 boilers that are not going to light.
So that box will tell the boiler switch over because National Grid says so. Right now it's going to say I can and stop.
Right.
Because National Grid's saying don't burn gas right now, you're going to get a huge fine. This thing says I'm not ready to, so I'm just going to sit here and wait until someone tells me what to do.
So just like, it doesn't happen like we used to. When I first started in the boiler business, when I knew there was a cold snap coming, it was all right, put a whole bunch of Speedy Dry, a case of degreaser, grab all my oil, gaskets for all oil strainers and everything. And if I was on night service, I knew I had a big week coming. Because I knew when that cold weather came, and even in New Jersey, people on interrupted service, they call us up, they call up the hospitals and say, hey, you've got 24 hours, you've got to switch over. And of course, nobody went and ran and checked to see if the oil foreigners worked. And they found out, 2 hours before the deadline, oh no, I got 2 out of 3 boilers that are running on oil. So when you know that weather's coming in, you're going to be switching over, you got to have these guns in.
Any special maintenance we need to be doing or checking other than the air compressor on the oil side?
On 2 oil,
There's a strainer on it over there.
yeah, right. You have the strainer on there. As long as you have the air filter, this is a fairly clean room. You can check it. I don't see having much problem with contaminations in there. I know around here, all around this northeast Jersey, you've got what's called Phragmites. It's all those fields. They're really bad in the fall. They all are the cattails is what they call them. They're really bad. They come in. You got there's an oil strainer in here that filters the oil out. Brand new, clean it. You can check it, clean it. Here you have this strainer on here. You spin it. There is a drain connection on the bottom that doesn't have a valve. You can put a valve on here. I would recommend if you're going to use a ball valve, put this plug on the bottom. Your pumps don't run all the time, but just to drain out.
One little blowdown on it.
Right, I put a blowdown on it. And what makes that easier to do, if you're ever going to do service on any of the components here, it gives you a nice clean place to be able to drain some of that oil out and make sure you got pressure off up here so you can safely work on the components of the oil regulator. It just it facilitates servicing the oil sides of the boiler.
There's a strainer further up the line.
Yeah, and the strainer there, it's almost the same. What it is, if internally they look like fins of a radiator, and that spinning has a comb. It's like a comb that you would buy to clean radiator fins or a condenser outside your air condenser. And as you turn that, the teeth they comb through there, and any solids that are in that oil are going to drop down. You got a new tank, fairly new lines. You know, you didn't have 4 or 6 oil in it before. Yeah, you're not going to see much stuff, but you never know. Yeah.
We're just burning B5.
That's it.
It's a whole different
A couple seasonal changes or cleanings. Pull the oil nozzle, clean it.
If you keep, like, if you're off and you said that you're going to be getting, they sell plugs. We can pull this out, and there's actually a plug that we can put in that the oil gun drawer. Keep it in there, and you'll see right here there's a hanger to actually put the gun on. We'll keep it out there.
This is kind of, I mean, somewhat good example of kind of what not to do, because putting it down there into who knows what could get outside particles to clog that nozzle. Really resting it here this is a twofold. One, a nice clean place to put it when not in service, and also 2, this is your holdback if you do need to open the nozzle.
Yeah.
So we gave wrenches, I believe they're sitting in the control panels, or at least they were. So this is a good place to put the oil nozzle, and then that's your hold, your vise.
It's a little tricky with the braided hoses to reach it. Yeah. It's a little tricky with the braided hoses, so you gotta roll them around. No, yeah. I mean, these hoses.
Oh yeah.
They don't like to give and bend.
Usually there's a little bit of a flip.
Right, they're a bit of a
Careful not
challenge.
to throw
Correct.
oil in weird places. but
The oil nozzle on these
I just
guns.
left it there so it drain and get it on the floor.
Well, the oil nozzle on these guns are a 2-piece component. It's a steel head with a brass swirler. They've been machined to match each other, and they're lapped. You want to be really careful with them, especially since you're doing 2 oil. There shouldn't be a lot of cleaning involved with them. You don't want to mix them up. You know, boiler, let's call this C or 3, I don't know which it is, but that's oil nozzle, should stay with that, and the 2 parts should stay together. You don't want to be aggressive. I've seen people take the nozzle out, and they take the brass component, and they go over to a bench grinder with a wire wheel, and they sit there on the wire wheel, and all of a sudden they look, they go, where'd all my grooves go? Because that brass component, it's all swirled on the top to help that atomizing air and oil mix together. You go and wear that out, or you're too aggressive with it, taking metal tools and scraping. They don't recommend that. Cleaver Rooks in their book says you're only supposed to use wooden like toothpicks to clean out the holes in them. I've used stuff like that before. One thing I always found, if you ever had the old push brooms, the old brooms with the wooden bristles, they always seem really good. They seem really good to use. Besides that, there's not much else really to clean on here. You have your pilot assembly on the burner. You can easily remove by 1 screw, and now the whole pilot assembly comes out. You have an electrode that's in there, and it's set up with a gap that's usually about 1/8 of an inch at the end of the tube. Old boilers, you had to pull the whole burner to get it out. Now with this new pilot assembly, you don't have to do that. You can pull the pilot assembly out with 1 shot. So with the burner too, you see you got a couple of bolts here. The gasket material, if I don't know if you guys do your own cleanings on the boilers?
Yeah, for the most part.
You do?
Yep.
So you're going to have a hard time when you want to pull this burner. You're going to get all these screws out, disconnect everything, and these bolts right here, they have 2 tapped holes. I believe they're 3/8. You'll be able to drive these in, and it'll break that seal. This gasket, it sticks over a period of time, and it's hard to get that out. Just make sure when you go and do that, you back them out, We've had some of our guys go and put the burners back after the cleaners.
Without backing it out?
Without backing them out.
Okay, now we need a new
And all of a
refractory.
sudden, well, what happens? They fire the boiler up, they got a suction air leak, they come in, oh, let me tighten up, or they come in with a gun, split the burner right in half. Very expensive F-up. This piece is not cheap. You're not getting that at Home Depot. Lever Brooks, I'm sure, charges a very pretty penny for that. One thing that's nice, all these servos are connected Modbus. They're all daisy chained in series, and they all have their own communication number. So now when you want to pull this burner, all you have to do is disconnect these Modbus connectors, drop them down. Now you don't have to disturb the setting of the servo to the air damper linkage. This way, when you put it back, everything's going to be right where it was. Also, like, it's usually a good idea, and Jimmy did do it, where the gears of this servo motor and the gears that are attached to the damper, he match marked them, tooth to tooth. So once you've got that tooth like that, if you ever have to pull this off, you put that back in there, you're dead on. You know, that's one important thing. Even like we don't recommend that customers do service on the fuel because you don't, unless you have a combustion analyzer, you're trained on how to set up fuel curves. We don't recommend that you do that, but you can remove something like that because doing that break, you know you went right back in the same point. And you can't do that by loosening set screws on a flat shaft and put it back in. The gas, oil, air, a very small deviation of where that was to where you put it back, your entire curve is going to be off to the point where it might not be safe. So that's just warning you with that. Safety limit controls, we went through that. One thing I didn't miss up here, here's two other Honeywell switches that are mounted on the front. One switch is a low combustion air switch, CAPS. That is making sure that when this boiler is in purge or it's firing, that I have enough air from the blower motor to maintain safety, and I have air to mix with my fuel. Next to it is a high air pressure switch. This motor is controlled by a VSD drive. The VSD drive does a number of things on this boiler. They're using it. Oh, you got to get your knee. The VSD controlling this motor, it gives you a soft start capability, so we're not starting up on full torque, really high amp draw. And then also what it's doing, this boiler has an O2 trim, and they're doing the O2 trim on the fuel-air ratio by increasing or decreasing the speed of this motor through the variable speed drive to maintain an oxygen level in the fuel compared to where it sets up. But I'll get into that later. Any questions on that? I think that's about all the safeties that we have. Eric, you said these boilers also have what's called isolation valves. You have motorized valves that are on the supply and the return. One of the lines, the supply.
Yeah. So the water leaving the boiler. Supply is boiler leaving the water. Return is the system coming back to the boiler. A little backwards when you look at the boiler.
Yeah.
Makes sense when you're looking at the system.
But also, now these valves, they open and close depending on if the boiler is running or not running. But also, up on top of there, to make sure that we have GPM flow through the boiler, you said there is a flow switch.
Yes.
So that's also another limit. That's just making sure that, and does the isolation valve have an end switch also, or no?
No end switch, but we have direct feedback. We give it a 4 to 20 signal, and we get a 4 to 20 signal coming back to us. So we know exactly where that is, and if that gets out of line, I believe 10%, then, you know, bells and whistles start to go.
So that's another limit. Besides the flow switch, it's also like I said earlier, we have 4 servo valves. They're doing the same principle. The PLC, the Allen Bradley, the Hawk controller, whenever I'm firing or even in standby, it's sending out a set point, an SP. Now there's a feedback coming back to the Modbus, which is PV, process value. If that's SP, the SP and the PV aren't within a certain percentage, I think it's like 1.5. If there's a deviation, it goes, something's wrong. It could be I have a bad motor. It could be I have something physically, wrong. I could have a linkage fall down and jam in here.
Yeah.
This cage, maybe a screw vibrated off, and now this safety cage somehow is interfering with the linkage, and it's not allowing this air to get back down to the proper position. That's another safety parameter that's built in combination with the servos and the processor.
I think the other, I guess it does still have low water cutoffs. I don't think we've touched on the low water cutoffs.
No, we haven't.
So even though it is a hot water boiler and designed to be obviously flooded 100% at all times, still required that we make sure the thing has water in it before we go to fire it. So we have two low water cutoffs of different styles. One being, kind of an electronic with just probes, a Warwick low water cutoff that has a little PCB board in here. The red light, you want to see the red light? Red light is good this time. If it kind of works like a backward spark plug. Sends electricity through a probe, wants to see it go through the water and come back on the ground, which the ground is the threads. So if you are servicing that, be very careful not to put anti-seize or Teflon tape or things like that, because we want to make sure that there is a solid current to be able to pass through the threads of the body and back into the circuit board. The other one is a very standard Warwick float that does have a manual reset on it. So if you look at the bottom of the flat square, there's going to be a little stick coming out. That's going to be a button for you to push. Please be gentle. No broomsticks. Don't attack that thing. It's not.
We can't reach that without proof.
Well, you're not going to be able to reach it from the chair. That's for sure.
It's not cheesy, it's industrial grade, but still when people get broomsticks, typically it's on the bigger boilers where it really is a ladder to get to it. People are swinging away at it.
Also on this side, which is the McDonnell Miller 150 float, you have what McDonnell Miller calls their blowdown check valves. You see up top and on the bottom at the cross tape, they just look like a heavy-duty cast iron fitting. What they are, since it's a hot water unit, it's not a steam unit. You would not be able to blow these units down and cause that to trip. My opinion, I don't want to blow it down, but I'm sure there was some regulation that says, hey, I need a way of testing this McDonnell Miller. So they put these check valves in north and south. So when you open up this blowdown valve on this McDonnell Miller, they're going to close, and you'll be able to drain the column of water out of there and do a test on that this McDonnell Miller 150. Word of caution: be very careful with these plugs when you take them out and you put them back in. Cast iron, it's a hot water unit. I don't know what kind of pressure you run at, but I'm sure it's not much.
20 pounds.
20 pounds. Don't have to be quarter turn Tommy. A little bit of Teflon, a little bit of never seize, set them in there, hand tight, maybe a half turn. Don't bury them because you'll crack these. I've done it. We've seen people do it.
Chinese iron.
Well, it's just that cast iron. Also with the electronics up here.
Chinese iron.
In my experience, if you have a problem with these, you have fork spades on the connections on the top of them, replace those. For some reason, you have a board, and here's your auxiliary low water cutoff, and it won't replace, kill the power, replace the two fork spades on there. I guarantee you turn the power back on, it's going to reset. It's a high voltage, low milliamp circuit. The wiring and the terminal banjo plugs, they just get a little bit of corrosion on there and you have a hard time making that circuit. to the point where we put a memo out with our guys. We do the summer cleanings, and it's like, guys, we're you know, customers charge us good money. It takes you 5 minutes to replace those, because almost every boiler we put back online, a day, 2 days later, we're going back in because they got a low water problem, and we got to replace those little connectors on there. Just a little thing to look out for. And say you have the hook on here, the Allen Bradley, but then also, I mean, the Allen Bradley is controlling your set points. It's controlling your servos, your combustion, the isolation valve. You can see all the screens you got on here. Setting up your O2 trim. But the safety mechanism of the boiler, the limits, and the flame supervision is all done through a Honeywell controller. It's the Honeywell 7800. And this is just a picture. We can see it on the screen. It's just the same controller that's used in a lot of boilers out there. It's nice here. You can see it. Everything that it's doing through a remote display, but it's on there. It's controlling the pre-purge of the boiler. It's controlling the trial for ignition, the flame supervision, the main fuel. It's looking at all your limits, your running interlocks, making sure that your air switch and your atomizing air and your oil pressure switch are all in the safety parameters to run. Just like any other boiler up there, because the Allen Bradley is not taking that part of the job. Other manufacturers like Siemens, they've integrated a control of this function into their controller. We have this, they're two separate components that are melded together.
Yeah, there's a lot of permitting required, because that Honeywell controller is truly what's keeping you safe, keeping this boiler in the room and not leaving it. So places like the city of New York don't really want to trust too many outside companies. They want a controller that they know is going to keep these boilers safe, and it's a whole process to get something else approved. So that's on the list of approved items, and it's a pretty good workhorse. I think the last main sort of interlocker safety switch is external to the boiler, which I'll speak to because it's kind of a little special here. Things external to the boiler are really just your brake glass. I believe that there's carbon monoxide monitoring in the room, and then your fresh air makeup. All of these things are external to us. We'll just touch on them briefly. We'll really let Johnson Controls do the real training on that situation. But it's my understanding that everything that I just mentioned, brake glass, carbon monoxide, and then the outside air limits are all tied into kind of a single relay, which then is monitored by JCI and then sent to us. This boiler will not run without proof that all three of those things are good and satisfied. Gets a little complicated here with the outdoor air. Probably you guys remember a couple years ago, before these two boilers were in, this was an entire wall of dampers, and boiler one froze, broke some pipes. So what they did, they blocked out the center ones, left the upper and the lower, and then got a really complicated system that when it's less than 50 degrees outside, those dampers shut, and a makeup air fan turns on with a heater in it. And then our safety switch, instead of being a little reed switch that monitors and makes sure that damper is open, it's now, I believe, a pressure differential, not even a flapper paddle. It's a pressure differential that proves, in fact, that the fan is operating and producing enough air to satisfy the boilers. So if that pressure differential were to trip, if this, the little reed switch on the dampers were to trip while the boiler is running, it's going to shut that boiler down because it says, hey, I can't run because I don't know. I got my actuators in the right spot, but I have no idea if I'm actually going to get the flow of air because I can't be guaranteed that the room is going to be full of air. So no boiler will start without that as well. think that is.
And that's Johnson Controls? That combustion fan right there?
Yeah, that's all in that magic panel. I think the relays themselves are in the green one that looks real old, because that was the original panel that was controlling the original boiler. But yeah, that's all being taken care of. I believe that black box is your carbon monoxide monitor. But again, that's all by other people. All we're looking for, we send a signal out, which I don't even think they're monitoring that. But typically we send a signal saying, hey, I would like to run. Please do whatever you need to do to give me air, whatever. And then we have a separate signal that just waits for that circuit to complete. So we send a request, and then we wait for all the limits in the line to come back to us, and then we proceed to the next step, which is to start our own internal boiler limit check and start our pre-purge cycle.
With the combustion, normally with the fresh air dampers, you have end switches that stops you from firing or stops your firing if there's a problem with that. With the differential pressure, is it a failure or is it the same thing, just a limit break?
That's a differential pressure switch. So being a switch, it's just yes or no, go or no go.
So the boilers they'd be dead in the water and like.
Correct.
So yeah, we have to figure out why.
Right. It would come up. So the thing with these boilers, the program that they have is when you trip on an external limit, which is brake glass, air, carbon monoxide, that is a manual reset on the boilers. So it's going to say right up at the top, external limit, broken, something like that. But it's going to say external limit circuit, and then right below that, it's going to say to reset, flip the burner switch off, flip burner switch back on. And that's going to be how you clear an external limit alarm. There's no reset button, but it tells you right there at the top, flip it off, flip it to on.
However, it won't clear it if the alarm still exists.
Right.
Yes.
Still have an alarm condition.
So we gotta figure out which alarm condition and clear that first.
But that at least gets you looking towards that JCI interlock system, which is brake glass, CO2, makeup air. Whether it's the damper, whether it's 50 degrees or more, like a day like today, we got the dampers open, or dead of winter, we got the makeup air system coming on.
Good, that answered a question for me. In case I come, I'll be hitting a reset button going, it's not doing anything.
There's also a manual override switch for the dampers.
Oh, okay.
Fail
Yes,
safe.
good.
There's a rib there on the bottom, handoff auto. It is the one with the red light staring at us.
Yeah.
That's the manual fail-safe to get those suckers open to get a boiler up and running.
Yeah.
While they're trying to figure out why the MAUs aren't working.
First thing, let's get a boiler going, then figure out why.
Then we find out what the problem is.
All right, so I went through the 7800, your flame safeguard. That's controlling the safety operation of the boiler. Now we have the Hawk. It's an Allen Bradley PLC control internally in here. I'll open it up and show you real quick.
You can use my screwdriver, it's sitting right there.
This is my... Are we allowed to open it with power?
Should be.
Yeah.
All right,
Don't put on your beekeeper suit.
yeah. So, the Allen Bradley processor, that's it right there. And then you have all these other components on here. You have a Modbus rack, you have an Ethernet rack. All the way to the left, you have a DC power transformer. You have the power transformer for the PLC rack. And then you have cards, digital input, digital output, analog input, analog output. Each one they have little LED lights on here that show everything is all copacetic. You see right now you're all running and you got all lights down. One thing that's nice to see, if all of a sudden I got an alarm and I can't clear it and I got a problem, usually if you have a problem with a card and 9 times out of 10 it's an analog card, you'll see your light stops. The card before it, that's where you lost your chain of command. Do not Do not touch any of these cards under power. Really don't touch them. You pull the card out under power, you wipe out all the programming on that program and everything. So, full service, you got a problem with it. Whole bunch of other relays, contactors, another power supply. You got a cooling fan. Keep all this equipment in here cool. Auxiliary low water cutoff. Eric was talking before whether or not your cutoff is going to be good. There's a little red light he was talking about. Like I said, they want everything now so you don't have to open electrical cabinets. So here's your burner control. I got an alarm, I got a red light on here. You got a reset on your 7800, which is external. It's wired to reset contacts on the 7800. I can hit this and I'll reset it. Let's see by doing that. I just did a test. Did a test. That's another function of the 7800. I got a burner control alarm on the Hawk. So now I can acknowledge it, and I cleared that. I go back. Also, and as you came in, it said auxiliary low water cutoff open. Here's your auxiliary low water cutoff reset, because that's also a manually reset. You press it, the alarm don't go away. I don't have my little red LED light saying everything's okay. Maybe you don't have water. Maybe it's those connections that I said need to be replaced. There's something loose, bad relay. But there's a good, that's a everything's good light. Right there. So unless that light's on, that boiler's not going to start. I said you got Modbus connections up here. One Modbus connection is going to your drive. That's communicating with the Hawk. The other Modbus connection is taking all the information from the 7800 and going to the Hawk. You got your Ethernet hub here. Ethernet, you're talking from your PLC to your HMI, your human interface, your display screen, and talking to other boilers, and talking to the Hawk panel, and maybe an end user PLC. Do you have like a remote?
Yeah, prototype.
SCADA?
Yeah, so each boiler is independently connected to the master panel by an Ethernet cable, about 4 or 5, 110 volt signal wires, and 2 communication wires, twisted pair, to give us a 4 to 20 signal. So that master panel will absorb all that information and then kick it out to the Johnson system by means of our protocol translator. So it speaks to BACnet.
Question, I know the boiler 1 has a master disconnect to kill the power coming in. Where's the master disconnect to kill the power coming in? On that one, it's separate from the drive. This one kills everything through the drive.
Correct. Your main power feed is entering in this panel.
Through that drive.
Through the drive.
So 2 and 3 are different. That one has a separate panel on it. It's got 2 disconnects.
Right,
One
it's got
for the
that.
drive and one for the
It's got the lower panel on that one. Yeah. So the main power on boiler 1, which is what you're used to, main power is coming in here. Then we send it to the VSD, and then we send it all that whole going back and forth.
The new one.
Streamline your main power feed terminated right here.
Okay.
You've got the kill switch, and then from there it branches out to feed the VSD, feed a 110 transformer, which is then going to power all your other stuff.
Correct.
So it has the main 3-phase disconnect here. That's going to kill the power, everything. Because all the secondary voltage, the 120 voltage, your DC voltage, is all coming off of there. You have a separate breaker right here, which normally is just for the rack, the PLC rack. We kind of recommend that you keep that off when you power up the boiler. You don't want power surges coming in. I don't know if down the road you guys ever think about getting interruptible power supplies.
There's been
Would
some
you
discussion.
recommend UPSs on this?
Yes.
They do monthly generator tests.
Yes.
It's only a 3 seconds, 5 seconds, it's off, it comes back on. But this thing has to go through a reboot every time
Yep.
that happens.
No, we have a lot, especially hospitals that are doing their tests. We put them in there, on there.
Would you or Eric, after this training, show me where to tie that UPS in?
Yep,
Thank you.
I could.
Because I can purchase 3 of them and the suckers will be in there before the next generator test.
And you got 2 options, you can do them both, but a lot of people just take the power downstream of the breaker and just use it on that. All they're doing the UPS for is the
It's plugged
PLC.
in. UPS gets plugged in so it knows the power went off.
Correct.
Yeah.
Right.
So that's why I need to
But-
tie in.
What he's going at is the only thing we want that UPS to power is the PLC. We don't
Okay.
want that feeding power into your limit strings, anything like that.
So
We
it's going to be
wanna
the outlet of that breaker.
Right,
Correct.
right. Which is
Yeah, I was
just
thinking I had to feed everything.
No.
no, we're just powering the PLC just to keep that program active. I don't even think the touchscreen stays alive.
Okay.
No, it will.
It will stay alive.
Yeah,
Okay,
yeah.
but again,
That's
Yeah, because it gets rebooted so often. That's why I'm questioning it.
yeah.
Thank you.
No, you're right. Yeah, it's got a separate power supply with that. So
Right, we're just trying to keep that program. The less we can
Slamming
cycle that
computers off and
PLC.
on is never a good thing.
Sometimes it is. Sometimes it's a good thing to turn it off and on,
Sometimes.
but not on a regular basis.
Correct. Gonna bite the bullet there?
All right, like I said, we got the PLC controller, and this is your display, your HMI. Right now, you're on your overview screen. That's normally the one screen that everybody likes to have. If we go back to screen select, it's going to have all your options. Time of day is, no way, it's 11 o'clock already.
Pulling right off here.
That's off. I have to set your, they don't have it on here, but here's where you can log in to make changes. Certain screens you can get out to. They're read screens, read only. But this is a read. But you also, what you can change on here is your firing rate. Right now we're on remote lead lag, which means that the master panel is controlling the operation of this boiler and the modulation of the boiler. But I could go to either manual or auto and run the boiler by itself. In either manual or auto, it's its own entity. Number 2 boiler doesn't know that 3-in-1 exists. It's running on its own independent set point.
There was
Is right here.
There was definitely a little confusion early on as to the difference between the 3 modes, manual, auto, remote lead lag. Remote lead lag is what it should be on pretty much 99% of the time, unless there's a problem somewhere along the line.
That way the
You
master
kinda limp it
panel's in
along.
control.
Right.
Calls for
Yeah.
it based on demand.
You'll see when we get to it that master has an available, unavailable light for each boiler. That will say unavailable if this is in auto. It needs to be remote lead lag for everything to work the way it's designed.
Yeah, if you have all 3 boilers in anything but remote lead lag, you're going to see 3 unavailables.
These 3 buttons here.
Yeah, but screen, this is why I'm looking
This
right now.
is a different screen.
Boiler number 1 and this boiler, possibly the same, is this one. Screen graphic absolutely different than on number 1.
You mean this graphic?
No, where we change, for example, firing rate from
I mean,
manual to...
So you could do that in combustion control. You
Okay.
can also do that in
Firing rate.
firing rate.
Okay, this
Yeah.
one, yeah.
Right. Yeah.
I was
We're using
going
this
to
one.
get to that. That firing rate, remote lead lag, or manual auto option is in actually 2 screens. It's in your firing rate screen and it's in the combustion control screen. The combustion control screen, it's a tool mainly a service techs like to use it. You know, I said before about having problems that I had, say, low fire hold. Something's wrong. The boiler won't start. Remember I mentioned before about SP and PV. Here is it showing all your servos. I have my air servo, my fuel servo, and I'm on natural gas, so it's only showing my natural gas servo. My FGR control, which is the flue gas servo, and my drive. It's showing a set point, and it's showing what my feedback is. You see all the numbers, they're pretty matched. I'm only off by 0.1% on there. That's within allowable. Now all of a sudden, if my air said I want to be at 11 and this was at 89, something's wrong. Something jammed up. My damper is stuck in the open position, or that servo is, and the boiler would never fire. So it's a good tool. Shows you what your oxygen is, where you're at, fire rate. You go back, You have your O2 trim, your isolation valve, where it is. Right now, this boiler is firing and it's still open. The valve is open 90%. You want to return. Diagnostics tells me, without having to pull out an electrical diagram and a meter, I can go right through and I can figure, hey, I got something open or something closed that's not. Really nice. Screen select. Isolation valve, we got into that. Set points. Set points, pretty much set your thermostat up. One thing I don't like, they make you do math. They used to just be able to do your on point, your off point. I don't know why they went to percentages. So it's an engineer wanting to make it difficult. Do you have an answer for that, Eric? Is it so you can get in?
I have no idea why they did that, but it is important to note about these. These set points are only on auto
Or manual?
or manual that come into play. When you put that to remote lead lag, it says screw whatever that is. I'm only going to listen to what that panel's telling me to do. If it's in that remote lead lag and that panel gets ripped off the wall, power tips to it, you're going to revert back to these set points. So it's good to have these dialed in, but you're not really going to be using them. You're really going to be changing things over there.
Because you got to realize, when you're trying to heat up the entire building, all these set points are being measured there, coming out of the boiler. When you're running remote lead lag, my measurement is at the end of the supply header. So naturally, the water coming out of here is going to be hotter than what I'm going to be trying to achieve there. I can be a 10, 15 degree difference greater than here than when I'm there. So if I'm trying to get 180 degrees out to the building, or at least from that point, I can never set my boiler at 180. By the time I got there, I might be 171, 169. So it's all relative. It all depends on the load, but just gotta keep an eye on that. Also, same reason, took the settings on here. I'm sure we've been running for a while, but we've had no problems. If I'm trying to hit 180 there, I couldn't really have a backup high limit set maybe 5-7 degrees over it. It would be a nuisance. So you gotta take all that into consideration.
I believe that high limit's set for around 210.
210? So, you're not doing any sort of outdoor reset or nothing, are we, on the temperatures? Are we a straight set point?
Straight set point.
Straight set point?
I mean, that's something that I believe
We're not doing-
Johnson has control.
They're doing a remote.
You guys can do that remotely, I believe. If Johnson isn't, they have the ability.
we're not
to
doing
do
any- I don't know what
they're
they're
taking advantage of that.
No, there's no outdoor reset. There's no outdoor reset at all because this thing is constantly providing water to the heat exchanger in the NRV building and to all the reheats over there.
So maybe
It's
you
all
can outdoor
designed for
reset.
180 degree or warmer water.
So there's no outdoor reset?
There's no outdoor air reset.
There's no remote
It's
set
a one
point?
and done.
No remote set point?
One and done.
Good. Then it's a mute point.
And also, these have a low limit on them where it won't go into high fire below 162 degrees.
Okay.
So we could never go below that anyway,
Yeah.
or it would just cause huge headaches. So no, there is no outdoor.
I don't know, they still have to step up the thermal shock.
Oh, it's in there.
Yeah.
Oh yeah, you come in here when it's off and the boiler's down to 100 degrees, and you let that run by itself.
Yeah.
I'll come back tomorrow to see if it's caught up yet, but it's never going to catch up because it won't
No,
ramp
right,
up.
yeah.
So you got to manually ramp it all up.
That's what I like.
I
The
showed
old-
all these guys. All these guys and I spent a little time.
Well, the old school, they had the low fire hold, and then they had the timer relay
Right.
parallel.
This constantly monitors and looks and monitors. This slowly ramps up.
Once we hit that 165 enough, it'll release from low fire hold, but then it doesn't. It does have like a 5-minute or so delay before it actually release to mod.
Right.
Just lets things settle out, I guess.
I got you. Alright, so go back to screen select, isolation valve. They got how to clean your screen. You can press that and you can wipe down the screen with Probably just a very clean, damp cloth. Don't want to use any solvents, greasers, anything like that. Just a damp cloth. Set points. Their alarms and limits. Can't get into it. That's something you can change, but I'll see if I can get into it right now. Won't let me get into it with that one. We're gonna see what it is. Unless I did something wrong. Let's try again. Right? Yeah. I must have shortened my finger. Must have missed a number right. Now return. Now we get in there. There's some more safeties that you have on the boiler. You actually have other sensors. You have combustion air. You also have a stack temperature sensor. We're monitoring stack temperature. If for some reason it got above 450 degrees, it's going to give you an alert. If you got above 500, it's going to shut you down. Sometimes you're running on oil, nobody saw that you're electing a pump, and all black smoke coming out of the chimney, sooting up the boiler, stack temperatures went up, that's going to get you out of there. Some people, they used to have a bias pot to limit the amount of input into the boiler. The PLC allows you to do it instead of with a dial, we can do it through a firing rate screen. Instead of the boiler going all the way up to 100% on either oil or gas, we can limit it. So high fire would be it's a 300 horsepower boiler, so we can, it's not linear, but we can do it 50% and approximately put you at like 150 horsepower high. Then some people have a time with cycling. Set point limiting, you can't go higher than 235 degrees. You have a low water alarm set point. You're not using it. So we can set that on the boilers to set it like, say, you never want to go below 160. That was that degree where you got stuck in low fire. So you can put it below that number and actually put an alarm and say, hey, it's time to warm up the boiler. But I believe return water is sitting around like 150 or so they'll naturally maintain themselves around 150, 145 to 155. I've seen them kind of naturally maintain themselves in gas station well. Also, low stack temperature hold. So we have there an on. There's your low temperature hold, but I believe that only works on auto or manual. I don't know if that probably works on a remote lead lag also. So if you're going from a cold start, it's not allowing, if this was on, it's not going to allow you to go to high fire or anything at a low fire until I get my stack temperature above that point. I get out of this screen, we go back to set points. There's on hot standby. So if any one of these boilers, or if this boiler drops below 165 degrees, in any of the firing rates, manual, auto, or remote lead lag, it's going to fire this boiler and warm it up until I get above 165 degrees, so it's all ready to go. So I don't know what the lead lag is, if they're only switching it every week. You might have one boiler handling the load this time of year, running all week. The other two boilers are stagnant. That's going to keep them hot. This way, if one boiler needs to come on in emergency, it's ready to go.
This is a good screen. You want to show them how to change a value? How to change a number?
I'll do our set point, because our set point is our modulation where we want to be. No? It's very easy. All you do, you go and press. Here you got to do math, but right now we're coming on at 185 degrees is what we're trying to maintain. So we're going to vary our fuel input to maintain 185. But we're going to shut off at 195. And if we shut off, we're not going to come back on until we get to 179.8. Because we had to do this minus 2.8 percentage point. Now, if we want to change, if we change the set point by pressing this button, it's 185 now, we're going to go to 190. Or we'll go 186. 186. Enter. 186 showed up there in that highlighted box. You go and press the set point, it changes to 186, and by doing that, and now that we have the percentages, I just answered my own question. By having percentages, if you change your set point, you automatically change your on and your off point, instead of having to go in and change three things.
You could easily have that +5, -5 though.
Yeah, right. But
it is a little autocomplete feature, which is nice.
Yeah.
But the big thing is, if you want to change any value that'll let you change,
that's how you do it.
hit the purple box, enter the number you want, and then place it where you want it to go. That's essentially how you change any value that it'll let you change.
Want to put it back to 185? Real easy. Go press that box. The only way to learn is to do it yourself. See the little pink box? Press it. Now punch in 185. Now hit
The big arrow.
The big arrow, the crooked arrow, bottom right corner.
Yep. Nope.
You just lost your 5. Now it's there. Now put it over to the set. Boom, boom. There you go.
Where? Okay, later.
Okay.
I'll write down the default set point for those who guys ever have a problem, or write it down inside the rule. So in case you find something wrong, you got a default filter. Keep your ass out of trouble until somebody can get it and get the search today.
And it is a little smart if you want to try and say change to 250. It's not going to let you put it there. Out of range. It's not going to let you do that.
Excuse me, Derek.
No,
and
no.
this screen is only available in operator, whatever the password was. I don't know if they want you to have it. There's factory and there's
I wouldn't do that.
Yeah,
I wouldn't do that without a password.
right. No, but you can't. But then there's other screens that you can't get into with that operator 3232. It's not going to let you. It's only going to be end user things that you can get at.
Correct. That's why I got 1-800 Miller chickens.
That's it. We appreciate your service. That's it.
Just get your ass here now.
Same thing. You know, with all these we can change, but within range. Go back to screen select, set for startup, system configure. All right. I said earlier, you have a blower VSD that's controlling the blower motor. You also have a screen for the VSD. This remote display, if you go in default, it doesn't have any really LED light going, hey, I got a problem. You're going to get a little tiny banner up here saying fault. You might not notice it, but it's going to come up on the banner up here. You got a VSD drive fault. There you're going to clear drive fault. I said earlier we are connected through a Modbus. It would show a fault on here. It's going to say what the fault is, fault status, and if it's recoverable, I can clear it here. I don't know if
Didn't see what screen you're in.
yeah, that's my VSD drive.
Okay.
I don't know. There's been a bulletin out from, and I forget the tech's name. It's from years ago. That was with the Hawks. They were since retired. But parameters with the drives, having problems, like you said, generator restarts, over voltage issues from motor regeneration. We've changed restart tries in the drives to eliminate that. I don't know if it's been done here. It's something that we can look into. It's helped. When it drives,
So the UPS doesn't protect the drive, it only protects.
yeah. Well, what'll happen with the motor? We'll shut.
If it's not getting a signal, it should go down anyway.
Well,
Almost like self-protect.
yeah. Well, what happens sometimes if you shut a boiler off, you blow it down, you turn the switch off, and you turn it right back on again. That motor is still winding down. Now the drive is sending power to it to start up again. That wind down voltage are conflicting. The drive sees it, it goes, I'm in a problem, and it locks out.
Basically, your motor becomes the
The
generator.
generator, exactly, over voltage. Cleaver Brooks has sent out a bulletin that we've been doing to all hospitals and stuff like that. I just had to do it with a DA with all, I had 4 feed pumps and 3 transfer pumps because with the on-off lead lag, it was causing all sorts of issues, so I had to do that to all the pumps. It helped. Just saying. But if you're going to drive fault, that's how you clear it. But we have no faults now. You see now we're firing. Give you a lot of information.
How to get back on that page from where you start all of this to come to
Hit screen select.
select, right? There.
There you go. See, and it shows you, it's showing you what your output amps are, your blower motor, the kilowatts, what RPM I'm running now. My set point of 185, my supply water 195. Now, the reason that is, because we're in remote lead lag.
Oh, okay, plastic.
We went back to our screen select. I apologize. I would have been shut off at 195. We're at 194 right now. But it's running this boiler off of the master panel.
It's the same, that's the
Yeah.
master.
Motor hertz, our combustion air temperature. That's good. Like when the wife says, "How was your day?" So, honey, it was 135 degrees, in that boiler room all day.
Is there a minimum combustion air temperature so we don't create condensation or
No,
some problems?
no, I don't believe there's.
Okay,
Nope.
just asking.
You'll see other issues before the flames
Yeah.
issues.
Okay.
I'm sure you guys see a lot of sweat coming in.
Minimum flue gas here. I said the wrong thing. Minimum flue gas.
There is. Well, there's a hole. Screen select. On rate. You're not using it. Stack low temperature hold.
Same thing as a low fire hole, just
Yeah.
for the flue. But we generally leave that off.
Yeah. Right now you're not utilizing it.
It's nice to know it's an option.
Yeah.
It becomes some kind of...
I believe the theory behind leaving that off is if the boiler is 165, you're not condensing. So it's kind of, you could do it either way.
Yeah.
Hold the boiler to 165 or limit the stack temp. They're very directly
Yes, absolutely. Yeah, that's why,
coordinated or whatever.
that's why I was questioning.
So if the boiler's at 160, condensation happens whenever return water is less than like a $1.40 or so.
Yep.
So if return water, the boiler is 165, you're not going to condense. That's just, no matter how much air, how little air, whatever you do with the fuel, you're not going to condense at 165. There's one, I guess, let's go screen select. So one thing I want to touch on is isolation valve, because on this front screen we can see that it affirms to you that the isolation valve is open. So we have these kind of status lights. We've got this manual auto. There is three real positions that this isolation valve is going to be in: closed, partially open, and full open. All dependent on load demand and the location of this burner switch. So if you hit this burner switch to off, valve will close 100%, and you'll get this valve closed light. We'll go to 0%, valve closed. Simply flipping it to on with no demand is going to give us this partially open, whatever it is, to maintain, a little bit of heat in the boiler.
165 or above.
Well, as close as we can get. It's all going to be determined by the return water temperature. We're never going to be above, whatever your return water temp is, within a couple of degrees of that is what this boiler will maintain. It will stay in this partially open position until the gas valve's open. Once the gas valve's open, it'll go wide open. The one thing that we saw the last time we were here, a nice kind of little feature is it also will not fully release to full open until you're up to temperature. If this valve is full open and you're still at 150 trying to clear that low fire hole, you'd have to heat the whole damn system up. It's gonna take too long. So it keeps itself throttled to keep a little bit of that heat bottled up in it. And then once it hits 165, it'll release to full valve open. So essentially, this burner switch must be on to get it partial open to keep the shell hot. This burner switch goes off, all bets are off, that valve's closed, the boiler's gonna go cold. So that's why we wanna leave it in on position in remote lead lag. That way, it'll keep itself warm, but not actually fire, and let the lead lag do its thing.
And some operators, chiefs, they're like, hey, I'm only using it. I got 3 boilers. There's no reason to have number 3 on. We're just gonna isolate it, but then we'll keep it off. But you never know. You never know what can happen in a day or two. So no reason. In my opinion, having the system water flow into the boiler and all the circuitry and everything all hot is better than having the boiler just sitting there stagnant. Like I saw one line on here about blowing down the boiler. Besides, if you're mandated to blow down this low water cutoff, it's a hot water unit. Ideally, in my opinion, the boiler from the day I put water in it, if I didn't have to open it up and drain it, I would. So a lot of blowdowns, not necessary.
We treat the water as closed loop.
It's that closed loop. That's why now a lot of inspectors are giving us 2-3 years that we don't have to drain boilers, and open them up. Every little bit of raw water that we get in there, it kills the boiler.
Just taking all your chemical, flushing it down the drain.
It was Tom Umbacher. You remember the trainer from Cleaver Brooks up in Milwaukee? He told a funny story. They had a big power plant with 2 hot water heating boilers. They kept going through tubes. They couldn't figure out where they were losing all the water. They put water meters in. They put dye in the water. They tried all this stuff. Finally, they had a big meeting to try to figure out where they're losing all this water. They had no idea. So the chief was on vacation that week. So all the principals get in the boiler room. They're starting their meeting. Well, the guy that took over the chief's place that day, he was a night shift guy. He comes in and he hooks up a hose to a hose bib that was on the side of the boiler, puts a nozzle on, brings out his mop bucket, and starts spraying the floor down with the boiler water. They all look at him and go, what are you doing? He says, hey, I got endless hot water and it's so much hotter than it makes cleaning the floors easy. So they all threw their hands up in the air and say, all these years, you try to figure out what the hell's going on. It was just one guy that didn't realize you don't waste that water like that.
But along with that, chemical, monitoring the chemical, whatever chemical guy you have, it's really, a lot of people ask us how long is a boiler supposed to last, or how long does a boiler last? You should be asking your chemical guy that, because it's all about how long those tubes will last. It all depends on chemical. Having a good chemical treatment guy, having a good chemical treatment program, strictly adhering to that is absolutely critical for getting 20, 30, 40 plus years out of these things.
Especially hot water units, oxygen is the #1 killer. Those tubes you'll never really see it build up on scale on them. So the steel is very susceptible to oxygen. And I don't know if you've seen it, it looks like chicken pox. You'll drain the boiler and you have all little like pustules scabbed over on the tubes. And what's happening underneath there, it's the pH, it's creating an acid and it eats through that tube. And once one gets it, they all have it. So I don't know how many tubes are in this boiler, just picking 250, one tube's got it, they all got that same condition. What happens, you go and dump that boiler. You replace that one tube that popped. And then you fill it up with fresh water. And now, I'll call the chemical guy, he comes at the end of the month. Now you got all that fresh water you put back in there.
Highly oxygenated water.
You got to get the sulfites and all the chemical levels back up there. You know, from day one, you fill this up, you got to make sure that sulfite levels, and I'm not a water treatment specialist, but I've seen it happen. I've seen 3 Cleaver Brooks 200 horsepower boilers ruined in 2 months because of a solenoid valve hung open on a feed tank. And the only thing that saved Miller and Chitty, they put a water meter on there. 16,000 gallons of water went into that tank and to the drain. And when I walked in, I had the water pouring over the 3-inch overflow to the drain. And all 3 of those boilers had to be retubed just because I got brand new boilers. We don't need to do any chemical treatment or nothing. The big mistake. So day 1. That's it. That's what you need to do. Any questions on any of the controls, the drives, the honk? I said everything's going to come up on there, and also too, what's nice, gives you an alarm history. Tells you all what you had, what the date was. 8/19. You had low gas. I guess that's when they came in and did work on the gas. So
Yeah.
they shut all the gas down, and that's what happened.
This is what I was going to ask. Look, we have, for example, a boiler treat or something like that. We have alarm. Let's say this one, fault 29, right?
Correct.
Lockout interlock.
Correct.
And 18, I don't see, all 3, I believe. Can we get a list of that fault, of that numbers, of message numbers,
This
to see what's going on exactly?
this is not an alert number. What this is your cycle number.
Yeah.
So does it tell me on, so right here, number of cycles,
Okay.
1951.
Okay.
So the reason it's telling you this is it's kind of helpful to say that the low gas pressure and the oil drawer switch alarm happened within the same cycle. So they're probably related.
About this one, fault, for example, fault 29, right? If
Yep.
we go page down, let's say page down, here we have a
Yep,
fault
yep, keep going.
29, 29, fault again 29, but
Yep.
we had the different numbers before. That fault 29, what it definitely means?
That's a running interlock, and it
I
doesn't
mean
really...
that what interlock, but where it was, what?
Lock. I mean, the only real description there, fault 29, is it continues to say it right after lockout interlock. That would be
yeah, but
your
what
running.
is it? For example, if it's a low water or something else or blah 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 whatever, can we find by this fault 20 fault numbers
Go
of
back
what
to
is
the
it?
go back to the diagnostic screen.
Okay, but before we go there,
Yeah.
they'll come in. You'll never get fault 20. I won't say never, but most of the times you're not going to get a fault 29 lockout interlock without another alarm coming through with it. So fault 29 interlock on cycle 1066
Burner
at 7:48 in the morning.
748.
You also had a burner control alarm. So you got that lockout interlock because something was wrong with the 780. Then you go to the 780 and look at that and say, what alarm is happening there? What you wanted to look at was diagnostics. So these are your cycles here. If you come in and that alarm is still active, you'll see, right there, saying that's true, saying that's false. Do they turn red when they're in alarm? I believe
Yeah.
they do. So saying if you went down on a high stack temperature, that would turn red and that's your problem.
On which screen is it? Can you show one?
Yep.
Screen select
diagnostic.
Okay.
So diagnostic, these are your two main ones. You know, water temp transmitter. So if it got too hot, non-recycle. This
And
is saying
some of them will be on the rail.
right. You can also come into your burner control, and it'll
if
give you
it's here also will
it'll
show
give you
what
further
was
detail
there.
on it,
What-
and it'll say right here, flame lost during pilot. You know, it'll put a description right here saying what the fault is.
My guess is, and I wouldn't really know definitely unless I went and looked at the electrical print, that that's a flow switch that's bouncing and causing that.
We were messing around with it.
Yeah,
that
so
day.
now to answer your question, you'll get, say, I was talking earlier about a restart on the drive. Shut the boiler off, turn the boiler back right on, right? Now the drive went and locked out, right? Now the drive locks out. I'm going to get on this screen, it's going to say drive fault. Now, hence my drive fault, now I'm going to go to start up the boiler. Now I'm going to have a combustion air switch fault. The combustion air switch is going to fault, and since there's 3 wires on there, that's going to send a signal back. It's going to say drive faulted, and then it's going to say combustion air fault, and then it's going to say lockout 29 because I lost my combustion air when it was trying to pre-purge. The 7800 is going to say I have a lockout 29 and a burner control alive. I've seen it. So you're going to have a drive fault, but they're all going to be stamped with the same cycle and the same date, all 4 of those drives.
Is it recommended, for example, if we do shut it, we need to reset it, not to turn immediately or 1, 2, 3.
You can reset it through here like you showed you.
Yeah, that's the best way to do it. Go back in, go to your return or screen select, reset drive.
Reset drive from
Then you go back to your burner control. You're going to have an alarm here because I got a 7800 alarm. And I got to reset my 7800. And then you're going to have to acknowledge all alarms. Once you do all 3, if that fails, you're going to have to do 3 resets.
This should never really be used as a reset.
Okay.
If there is an alarm,
But
you've
we
got
have
these
a reset button here.
That's an overload.
Okay.
Yeah. I mean, just try it.
That means it's trapped.
There's no harm in hitting that overload reset.
No, it's not
Hit
trapped.
these guys, and then if it truly is a problem with the blower, there would be. It was right there, right?
Yeah.
Clear drive fault.
Yeah, and you would have the fault would be here.
But
Take one of the legs off and see what happens.
better to do it, you know, with the buttons, physical
Come on.
buttons, or the clear buttons here, than to just cycle the whole power, because that's just going to cause even more alarms on here, and it's just going to further confuse you.
Let's reverse the phase. Let's do something
Just,
interesting.
we use, you ever hear of PK Mechanical?
Yep.
Yeah, well, the guy Mike, he was tying in a rental boiler last week, and thank God he had his monkey suit on, because something fell across the bus bars.
Oh!
And the only thing that happened to him, he lost his vision for about 15 minutes and his hearing for about 3 hours. He's lucky he had the full flame retardant suit on and the mask, otherwise he would have been dead right now.
Yep.
So I've seen enough of those videos. I don't want to. I don't ever want.
Curiosity.
Some bottling plant up in North Jersey.
Locally. Okay.
Yep. All right, so yeah, so that's clearing alarms on there. We went through all the settings, interface screens. We've been doing that. Changeover, boiler startup, pre-startup checks. I mean, I'm sure do you guys all keep a log, come around, make sure, you know, just, you know, you got your boilers running 24/7, 365. So, but I guess you come through and you walk around and just make sure, hey, everything's good. Now I got no oil leaks. I don't smell any gas. Everything looks good. Take a quick look around and make sure that I don't see any linkage that seems to be off. I mean, it wouldn't hurt if I showed you earlier. You go into this screen select. If you went into this combustion control, like I said, all those numbers should match. Your SPs and your PVs should match. You're going to get it's going to say low fire switch not made. The first time it happened to me, and if you remember, there was a Honeywell damper motors that were mounted on all the boilers, and they had 2 micro switches. So I'm like, where's the low fire switch? Where's the low fire switch? I wasn't used to this. I'm looking all over, and I called Jimmy. And Jimmy goes, there is no low fire switch. It's
Inside the
It's
motor.
inside the. Well, no, it's inside. It's the processor.
Right?
Yep.
Like a couple of years ago.
Well, this is it. The computer knowing I am at low fire.
If
There
you
is
see,
no switch.
you look at the bottom. They're all
like the feedback.
flashing, all at low fire.
No mechanical
So,
switch.
yeah,
it's a
because
Because this
feedback.
is when they're going in and doing their combustion tuning, they say, I want all these set points at low fire.
Yeah.
And they say, you know, the computer asks it, where should I, what is low fire? Low fire. Where should I be? Answer those questions.
Yeah.
And now it knows forever and all time until it's changed.
Yeah.
When all my actuators are in these positions, it's low fire.
Yeah, most likely, I'm not sure if this is low fire or light off. Normally, Jimmy and I, we make light off and low fire the same position. I don't see any reason. We never had a light off and a low fire position when we had linkage. Why would we need it with parallel positioning? That's just our opinion. We've seen guys make them crazy changes, but we like to keep it the same on that. So this way you know that's where you're lighting off at. You know, make sure that, hey, I got no water leaks. Everything looks good, you know. Going around, making sure my doors are all tight. You all know, you've been in boiler rooms for a long time. Lots of times you use all your senses. Something smells wrong. Hey, I walk in the door, I got oil. I smell oil. All of a sudden, the boiler on the end, you got a loose fitting, and you're spraying oil whenever it fires, or you know, there's a combustion smell in the boiler room. You got a leaky gasket. Hearing, man, that whine, that motor. You know, it's like I got a bearing going. I got a loose fan blade. All these air compressors, they got a cooling fan on there. Set screws loosen up. That don't sound right. That's not like what it sounded like yesterday. Little things like that. Just walking through the boiler room, just making sure everything's copacetic. Making sure that all the boilers don't have any faults. Now, everything is Modbus and Ethernet connecting, so all the communications that are going back and forth, I'm sure it's going to an end user and it's going to tell you what you got in there. So, we went over, you have auto fuel changeover. You know, you have an outdoor sensor, and when it drops below certain degrees, as long as those guns are in, all the oil lines are open, the fuel is ready to go. The boiler, and I don't believe it does a flying changeover, correct, Eric? No. The boiler, it's gonna say, hey, I just got a signal to change down from gas to oil because it dropped below that magical number, 15 degrees. The boiler's gonna shut down, go through post-purge, change some settings or relays electrically in here, and it's gonna go back over to oil and do its whole startup process, but now on a different fuel. And it's gonna run that way until you get above that magic set point. And then it's just going to do the same process, but in reverse and go back to natural gas. All on its own. We went over local remote operation. Pretty much went through everything on this list from what I can see. The only thing that we really have to cover on this list is the master panel. We went before. The master panel is a sequencer, lead lag, operating control for all 3 boilers. Almost the same principle as all the PLC. It's Allen Bradley's. You got a rack PLC. It's got all digital cards, analog cards. We have a sensor. Same sort of log in, log out. Screens kind of almost look the same. Here's our overview screen right there. No boilers are required. We have a set point of 180. We got 188 degrees going past that sensor right now at the end of the supply. So, no boilers required. We have boiler 1, boiler 2, boiler 3. They have their own IP addresses, 101, 102, 103. Boiler number 1, I assume, is the one all the way on the left. And that switch is off, it's not being used, unavailable. Below it, you'll see that you have a lead lag that was set in there. It wants boiler 2 to be number 1 boiler, your lead. It wants number 1, or the way the sequence is programmed in, it wanted 1 to be your first lag, and it wanted number 3 to be your second. Well, since number 1 is unavailable, it automatically made the decision that we're just going 1 and 2, and number 1 and 3, 2 and 3. Sorry, I misspoke. And 1 is taken out of the sequence. So right now, out of the 3 boilers, you only have a 2 boiler lead lag system. If you had a boiler call to run, it would start bringing a boiler online and fire that boiler to get to where our set point is. If we look at set points and sequencing, here we go. Operating set point limits, that's high and as low you can go. You got a low water alarm. With your lead lag, you got a rotation every 7 days. You're not using it right now. You got a set point ramp rate. No matter how many degrees below your set point, you're only going to be able to go up 1 degree every second. That's changing also in there. Here's how you change your lead lag. Go back to setup number 1. This is how it changes the lead lag boilers as you're firing. So what happens, it brings on, you drop below your set point. It calls for a boiler to come on. That lead boiler starts to fire. It's running, it's trying to achieve up to its set point. As it's ramping up its output, its firing rate, once you get to 80% or above, it's going to start a time delay timer. After that time delay timer runs out, here it's 300 seconds, it's going to bring on another boiler to help the lead boiler. Now what's going to happen, that second boiler, correct me if I'm wrong, that lag boiler is going to run from 0 up to 80% also. Then once that gets to 80%, now you're going to have 2 boilers at 80%. You're going to have the timer start again, and that's going to bring on another boiler if needed. They're going to run, if you start closing up to your at 80%, you start achieving your set point, it's going to start dropping back in the firing rate. Once you get below 50%, and a time delay, it's going to start dropping off that lag boiler to try to, so you don't overshoot your set point. All these numbers, they could be default or they could have been changed. No building is the same, no system is the same. Things can change. You can play with these numbers, and you would do it just like you saw before. Some people want to bring a boiler on faster, you know. Sometimes if you had a temperature graph and you saw your temperature doing this, you know, like oscillating, like oscilloscopes, go, hey, I got to change these numbers because I don't want to, heating, it's not as critical, but if it was processed and you started seeing your steam and your temperature doing that, we'd want to hone in on them settings. I mean, ideally, we want to see a nice straight line. Perfect world, I want to see a boiler start and run and maintain a constant temperature and never shut off once we're in the heating system. I mean, we're not going to do it now because what are you using? Reheats. There's no load, or I don't know what you're doing. But perfect world, that boiler fires and just runs. See, and then here, you can also take a boiler out of line. There's other settings to warm up boilers. You can also warm up boilers. I guess there's a temperature setting in here. Or this does the same thing as
These, I believe, would be to actually fire it, to warm it up.
from this screen.
Right. If you wanted to actually do a fireside, hot standby. Like if you wanted to actually truly maintain 165 as your hot standby, you can't do that with return water because return water is only about 150. So you need to make up that extra 15 degrees by turning the flame on, which you'd do from this screen where you could turn on the actual warm-up functions, where the master panel would watch that temperature of the boiler and fire that to maintain its lowest set point, which we deemed during the startup portion that your situation, it doesn't necessarily make sense because of the extended period of time, these boilers both being off for a week. Well, actually, each boiler would be off for 2-week periods at a time because you're not changing leads for every 7 days. So that means, it's going to be 2 weeks. On the 3rd week, the boiler will fire. So trying to intermittently fire that thing to maintain 165 degrees, really, ready to fire at a moment's notice, you're not a process plant. If the temperature drops for a couple minutes as that boiler is trying to heat up, no one's going to notice a 10-minute lag in 180 degree outlet. So if it was a process plant and you needed that immediate hot standby to kick on in a second's notice, that's when we use these warm-up functions to keep that boiler nice and toasty hot so it can come on in a snap. So we just keep the isolation valves, keep you warm, keep the shell expanded, and that's good enough for the long-term longevity.
So you see right there, that's your same like your fire rate screen, your on point, your off point, and your set point. And then you have your output, which is a CV. It's the percentage of output that they're putting out, where they did with all that percentages of how much demand it's putting out there to achieve the set point. That's going to be split up between the 3 boilers as needed. 2 boilers now. And it's in auto. That's another thing you might want to make sure with a lot of these screens that they're in this screen in auto. Also, it should never be touched. The only way I really ever see it happen, which I never really got into with the boilers, just to go back, we have an O2 trim. We set up a fuel curve on oil and gas, and at each point in the curve, it has an O2 reading that we're reading through that O2 sensor. O2 levels in the fuel curve change on conditions in the atmosphere, temperature, pressure, and humidity. Depending on those 3 things, there's less or more amount of oxygen in the air that the boiler is sucking in and mixing in with the fuel. To change that and to compensate for those changes, we use an O2 trim by increasing or slowing down the fan to decrease or increase the amount of air going in to match the fuel. There is a screen, the fuel gas trim. That should always be in auto. 50% means that I am right there. My number is what I set the boiler up at. Say at low fire it was 6%. When I'm in low fire, I'm reading 6%. If I turn out that I'm reading 8%, that means I got 2% more air than I set it up as. And what it's going to do, it's automatically going to start slowing down that fan to get me to that set point. We'll only do that if it's in auto. So that's something you want to make sure that it's always that way. Really shouldn't go into any of these screens. For the most part, most of them are what they call read. You just want to look in there, and you should never really have to change anything. Besides that, I don't know, anybody have any questions regarding anything on the boilers? One thing, like I said before about walking around, you got your safety valves. You start seeing any lifting or anything on those, you want to you want to address that. I don't know if you have air vents on these boilers to drain the boilers, but you don't want to use the safety valve as a vent. I see a lot of people go and do that. I don't see any vents. Oh, no, you have one up on the main shelf. So you see there's a big ball valve up there with a plug on there. See, a lot of people, they don't want to do that, so they go up and they take that handle of the safety valve and they bend it up, they jam a block of wood underneath there or something like that. Not good. Usually what happens, you're going to put the boiler back online and now the safety valve leaks.
Fire and relief valve.
Yeah.
I mean,
Most places, go ahead, I'm sorry.
No, I was gonna say, you're really only gonna have that, you know, if you're doing a water side inspection, is the time that you would really be doing that.
Yep.
When you're, you know, you got your system isolation valves closed, and you're trying to drain the boiler so you can inspect a manhole or something like that, or if a manhole starts to leak and you gotta change that gasket, you gotta open that vent, you know, drain it to bleed the pressure off. Once you bleed all the pressure off, then you can come up, open that vent. If you try and just drain it, it's going to go extremely slow, and these boilers are meant to hold pressure in, not hold back a vacuum.
Yeah.
So you can cause a lot of issues with things trying to suck itself in. So that you need to let some oxygen in there to drain it down.
That's it. Drain the vacuum, you're never going to be able to drain it. Any other questions?
I think that's
about it.
yeah.
Okay.
We're good.
Thank you very much.
All right, guys.
Okay, you guys all know me, Eric from North Nicholas. So we are talking about the new fuel oil system that is adding redundancy to your existing system. Just a quick overview of what was here, what we added, or what was added in the construction was we had outside a fuel tank with monitoring panel with pumps mounted on top of it with its own control panel, and then we were sending oil up to the day tank up here, the black one behind you, and an existing generator. This phase of the construction was simply adding one of everything and adding the ability to cross-connect in between in every which way, shape, or form. So with that comes, of course, another tank, another pump, monitoring panels, control panels outside, another day tank, and another generator. We also have added a fifth panel, which is up here, which is kind of the controller to go back and forth between panels, between systems, sorry. Kind of moving forward, at least for training purposes, you'll hear me refer to them as System 1, Fuel Oil Tank 1, System 2, Fuel Oil Tank 2. I'm going to consider those interchangeable, and we're just talking about so Fuel Oil Tank 1 or System 1 would be the existing tank, existing pumps, existing control panel. System 2, Fuel Oil Tank 2 would be talking about the new tank, new pumps, etc. Slightly including the day tanks in each of those systems. Why I say slightly is because we're still going to be flipping these back and forth in terms of the system. So this system can be set up in any orientation that you guys want. In terms of, do we want generally both generators to run off of a single day tank I mean, and then have alternating pumps outside control that? Or do we have everything kind of set up independently? So generator 2 runs off of day tank 2, runs off of tank 2 on normal operation, but then the other old system would run on its own, basically keeping them completely separate unless you need to do some cross-connecting. I'm not sure if that's how we want to do it, or if both generators will run off of this tank, and then if there's a problem, then we switch to the other tank. That's kind of going to have to shake itself out, or really be up to you guys, because it's just comes down to personal preference. They're both all good sound options.
How many gallons of this tank?
When?
How many gallons of this tank?
Oh, each of these day tanks are 100% capacity of 250 gallons. The working capacity, which is always 90%, 225. So we matched the existing. It's just a different shape. Just a little longer than it is tall than that one. The other difference being this is an open dike, where that one is a closed dike system. All the basic components here are the same. We have a level gauge, which this one is giving you inches to empty. So basically, how much oil, how tall is the oil in the tank? Where the other one was just simply E to F, like you see in your truck. This one's a little bit more helpful, where you could do some math and figure out exactly how many gallons are in there, rather than just kind of guessing. We also have a leak sensor in case the inner tank fails, or if any of the kind of couplings or something start to leak and overflow, which is the added benefit of being open, is we'll basically be monitoring these, any of these top tank connections, in case they start to leak, where the other one would just simply be running out over the tank. That one still does have a leak sensor. It's just threaded into the top, and it looks just like anything else. Here we have the overflow, which has a three-way valve, so we can send that to either tank. I'll discuss that later. We have takeoffs for the generator. Generator 2, we have takeoffs for supply and return on generator 1. We got fill, and we have a vent. This vent, I believe, is going up, yeah, this vent is going up to the roof. That one is the fill from the system. And we will have 2 level probes. This one is actually in operation right now. And that one will be installed shortly. To fill the system, right now we're relying on this level switch, which is actually nice that we don't have this installed, because I can use this for show and tell. So this is identical in every way to this one, and almost identical to the new probes that are put into the old tank. Almost identical for that, just because since they're different dimensions, the sizing, where these floats actually sit, are slightly different for that tank than this one. So we've got 4 floats on each probe. We have a low alarm that will, obviously go off if the tank is low. We have a high alarm if the level, gets too high. And then these 2 middle ones are not alarms. They are just simply control points. So in a normal situation, these 2 will be floating. Right, we'll say the normal level of the oil is here. These 2 will be floating, and then the other 2 will be down. So as that level starts to drop, this will eventually settle down, and it'll kick the pumps on. So push that right up, and the pumps will keep running until it pushes this float up, and that's stop pump. So I call this low alarm, pump start, pump stop, high alarm. So say this is up, pump just keeps going, and this fails to shut it off, then this will kill it. Conversely, if level keeps dropping, pump fails to come on, level will keep dropping, and then this will fall and cause the alarm. There is no real automatic switchover. in this system at all. So if it were to be a low alarm, that would have to be addressed manually. And so we have, the reason we have 2 level probes is because we have 2 systems involved. So each level probe, they're marked here on, we'll put labels for each one so you know exactly which level probe is doing what and controlling what. This level probe is controlling the brand new system, the new controller, new pumps, new tank. So they're going to sit, since they're sitting at the same height, each system, system 1 and system 2, will get the same exact signals of low, pump on, pump off, pump stop. They'll get the exact same signals, and it's up to that controller there. So when both of them see, okay, pump on, they're both going to want to start because they see it at the exact same time. That controller says, no, system 1, hang on, system 2 is in the lead right now. So that's being changed and switched from that panel right there. What fuel tank is going to supply these tanks is controlled right there. So when you flip between fuel tank 1 and fuel tank 2, you are also flipping between these level probes as well. So fuel tank 2 only looks at this probe, doesn't see this probe at all, has no idea this exists. The existing fuel tank 1 only looks at this probe, doesn't know this exists. So that's why we have 2. It's just adding to the redundancy. Say, you know, it's the ultimate problem is one of these little floats. Well, that's fine, we got another set. Similarly, if you look above us, so what happens when that level probe says, okay, my tank is empty, I need to be filled? First thing it does is it opens up a solenoid valve, and then it starts the pump. So each tank now has 4 solenoid valves. 1 for each system to fill each day tank. So we have, coming through this wall is the main, we'll just say this meter here is the main fill for both day tanks. So coming through on the other side of this wall is the boiler room, where we have the old double wall containment piping coming up, and then that comes this way. This pipe coming from the left is the system number 2, is the new system. So this pipe coming from the left is the new system. So they'll come in together and come this way. And so this single meter, this single pipe is common to both systems. And then we come through and we branch off into the 4 solenoid valves. So if this tank is being filled by system number 2, the oil is going to come through the small pipe there, take a left, go through the green valve, go through the meter, and then run through this lower solenoid valve. The pump 2 can control this one. The pump number 1 controls the upper one. What's that? Okay. Okay. So pump 1 controls the upper one, pump 2 controls the lower one. So when that says, I need oil in this tank, we open up the lower valve, start the pump, starts to fill with oil. One thing to keep in mind is if the boilers are running, there's no chance of deadheading this, I should say as well. Is if the pump is running and all these valves are closed, no big deal. It's all common to the boiler system. So we're going to create a common loop with the boiler system. So it doesn't matter if all these valves are closed and the pump is on, it's just going to go through the boiler loop, through the back pressure regulating valve and back to the tank and just circulate like that all day long and be happy. So we could start the pump first, and then just whatever solenoid valve needs to be open to fill the respective tank. There's been some confusion in terms of looking at the drawings and the way that it was laid out and drawn, showing one solenoid valve directly below the other, thinking that one is the standby valve or you know I guess standby valve, saying if one fails to open the other one. Doesn't really work that way. It's more intended to be, if that doesn't work, switch the whole system over, and then we'll use the entire other system. Similar for this tank to that tank, the only real difference is the existing valve is slightly smaller. For some reason, we stepped up the line size when we put in the new system. So you can always know that the smaller valve there is for the existing old system, and the larger valve is for the new system. As you can see, all these valves have been freshly upgraded with the stainless steel rod coming out the bottom and that conduit box on the bottom. What that is a position indicator. That will tell us if the valve is closed. So if tank is calling for oil, it tells the pump controller to open the valve and start the pump. If it then, that panel is then monitoring everything, it's just keeping an eye on everything. If it sees I have a pump that is trying to fill a tank and its respective solenoid valve isn't open, physically open, there's a problem. It waits 30 seconds just to make sure that everything's got enough time to do its movement, and then it will cause an alarm. Just saying, hey, solenoid valve isn't open for whatever reason. Whether the coil burnt out, or circuit breaker popped downstairs, any number of things, you'll get an alarm up here on the BMS. Switching between systems. Eventually, soon, we will have both systems fully up and running again. System 1 is still down for a final tweak and upgrade to make it talk well with the other system. And once that's complete, then we'll have full ability to be flipping back and forth between systems. So it's important that we go over what valves need to be changed. There is a valve chart up above whatever that piece of equipment is. North Shore put it together. All the valves are tagged, but it's all just changing three-way valves. So we have a three-way valve on each overflow for each day tank, and we have, I believe it's not a three-way valve, I believe it's two ball valves on the return lines. So we need to really focus on, at least in terms of fuel oil storage tanks and day tanks, the big crucial element is where is the return oil going. We don't really need to worry about what tank is feeding oil up. We need to more be worried about where is the oil going if it comes back to the tank. Because the problem with that is you have the potential to pump oil from one tank and pump it into the other tank if the valves are not aligned correctly. And that would then be, if both tanks are full, you're going to overflow one of them pretty quick. So that's the problem that we want to try and avoid, is sending oil to the wrong tank. So we want to make sure that the switch, that this selector panel up here, switching fuel oil system 1, fuel oil system 2, is in line with every tank that wants to, or every situation where oil could go back to the tank. which means overflows or returns back to the storage tank, and that main return oil from the boiler goes back to the tank. So everything's marked. This is overflow from day tank 2, and then there's a three-way valve which has, 2 fuel oil tank 1, 2 fuel oil tank 2. Same thing on this one. You have 2 fuel oil tank 1, 2 fuel oil tank 2, and on the other wall, we can look at that in a moment. You'll have the same thing. Little less, I'll say secondary would be the generator takeoffs. Same concept is we want to make sure that both of these valves are lined up in the same orientation for the day tank. Because again, with the generator, you would have the ability to take a suction on this tank and incorrectly put it to that tank. We get a little bit protected because this tank will simply just overflow to the other storage tank, but then there's a possibility then that the system would fill this one, generator would pump it, and it would be kind of like a cascading effect, and eventually, much slower, but eventually that the outer storage tank could still overflow in that situation. Up here, everything else is also greatly labeled, saying from day tank fuel supply, fuel return, to and from the day tanks and the generators. Between the day tanks and the generators. So day tank 2, day tank 1, these are your three-way valves. They can be, since they are three-way valves, they can be changed while the generator is running. And that's not going to interrupt anything. You can just move them both at the same time. You'll never be able to close or stop or deadhead anything by moving at the same time. So you have these 2 valves for the new generator, and you have similar valves, just slightly lower for the old system. And again, that's just saying which generator is running off of which tank. So whether that's normally Gen 1, Tank 1, Gen 2, Tank 2, it's up to you guys how you guys want to run that. So one thing over on the old black panel, you can kind of move around a little bit. So again, these are new, just slightly different lengths. These level probes as to the old ones. As to the ones for that tank. Leak switch, and then this is this was part of the old system that was really hacked together. I don't know how it ended up this way, but one way or another it was pretty hacked together, saying this box and this transformer were all part of the old system in terms of operation. Watching the day tank, sending the signal down to the generator, etc. We are now transferred fully over to the way that it should have been done in the first place, and we have proper wires. That said, this box can't be fully demoed. Most of the parts and pieces in here are bust and useless, with the exception of these 2. Which, if you read the wire tags, the signal from the boiler, when the boiler wants to run on oil, it comes into this panel and then sends it down to the pump sets downstairs. So we'll do a better job of marking these 2, but all the guts, all those bits and pieces in there are useless at this point. It's just this two pair of wires. This is your saving grace for the boilers to start the oil pumps. Everything else, this crazy power system, that all is bust at this point.
Is this gonna be demoed? Right here, above his head?
Um,
Right here, right here, right here.
oh, I mean, again, that's part of the old hashing things together. That is 110 volts. That is being powered in some way. There's no wiring diagrams for this. This was all just kind of like hacked together. So it was, in terms of construction, when construction came in, we assumed that everything was wired per the original wiring diagrams, and then came in and found that no, that was certainly not the case. So you can see that got pulled back, and we pulled in the proper wires. So that's 110 volts, where these solenoids are all 460. So that was never, since construction was coming in and didn't even know that existed, that was never part of construction to do all that demo. So I don't know what the state of that would be. But that is, all intents and purposes.
Right.
I don't know if it's live or not. But it's no longer needed. And I don't even know what breaker is powering this. So that was just we're going to leave that right there. I believe. So one other thing, I think the last thing that I have for up here is the, I guess 2 more things. Leak sensor on this tank, leak sensor on that tank. Much like these, where each tank system downstairs needs its own probe, we also need to split the signal for the day tank leak sensor. Since we didn't have any additional ports for things like that, we split it in that panel with relays. So this leak sensor engages a relay, which then sends it the same signal to both panels and isolates them electrically. Same thing with that sensor. Also, all with relay logic, so it's nice and reliable, we take 3 alarm points from each tank and send it to the generator panel, to the ASCO, to the switchboard. We send leak, day tank high, day tank low. Those 3 statuses get put onto red indicator lights on the main switchboard by the TVs there. That's all just relay-based redundancies, just so it pops up in every place imaginable.
Getting back to the return,
Yeah, ask away.
you want to make sure we have tank number 1 on the ramp feeding all this.
Mm-hmm.
We want to make sure this is valve to return the tank 1.
Correct. Correct.
We
That's
don't do anything to the tank 2.
right. So we
Override
don't.
it or switch from
So
one.
we don't move oil from one
one
tank to
tank.
another. So what would happen eventually, say if both tanks were at 50%, eventually you're going to get, because those tanks are monitored for high levels. So it's not just going to be magically oil on the floor out there. You will hit the 90% high limit. And then if it continues, you will hit the 95% high limit. So if you are just sitting there on a normal day and the boilers are running on oil, and suddenly you have a high limit on one of the tanks and a low limit on the other tank, well, looks like oil got pumped from one tank to another. So you will have some warning there. It's not going to be immediate, and it's not going to be without warning. But naturally best to avoid that situation if we can. And the only way to do that is to be very, very deliberate with the 3-way valves and where that switch is. that switch on that panel to control which pump is going to come on also works for the boiler system. So you got to think of it as any demand for oil is only going to start one system. And that switch tells the fuel oil system which system to turn on. Whether that's a boiler call or a day tank is low, it's all more or less going to feed through that. Not directly feed through it, but that sends a do not start. It's opposite. So if that's switched to fuel oil tank 1, fuel oil tank 2 like it is right now, it sends a do not start signal to fuel oil tank number 1. Because, as I was mentioning before, they both get the same call at the same time. Each fuel system sees the exact same picture through its own devices as the other one does. One of them needs to be told, chill out, I don't want you to run, and let the other one run. So it's a kind of proof of a negative, where that switch is not necessarily telling system number 2 to come on, it's telling system number 1 do not come on. Which, the reason we designed it that way, it's a little bit safer, a little bit lower chance. We'd rather see both systems come on than no systems come on. So if that fails to send the do not start signal, not the end of the world. If it failed to send the do not start, you could be running, dark with no heat and no electricity. So it's a little bit safer in terms of a system to be sending a do not start than a do not stop. I might have mixed that last one up, but I think the point's getting across. There are also, I believe, I forget exactly the wording on these switches, solenoid valves, day tank number 1, off and auto. These are the other switches down here. That is essentially for situations like this, or apparently every once in a while a day tank will need to be taken down for recertification. I think that was like once every 10 years or something. But if for some reason there was a problem, or say a day tank started to leak, say that day tank started to leak or something like that, and you couldn't use it anymore, simply switch it to off. It's not necessarily, flipping it to auto is immediately going to fill it. That's why we were very specific to say off and auto and not off and on, because we're not flipping the switch doesn't turn the pump on and start to fill it manually. It just simply allows it to run off of the float system. So auto is just do whatever it needs to do to maintain the float system. Off is don't open the solenoid valves for that tank. So this single switch will work for both systems' solenoid valves. It just says do not open those valves under any circumstances when this is off. So that could be if they both erroneously got turned off and everything's low, that could be a reason, we got to switch that back to auto. On the screen, there's not much that's going to be shown or displayed. It's a pretty simple system. Just simply says fuel tank 1 is in standby right now. For some reason, fuel tank 2 is an alarm. We can look at that when we get out there. There's a silent, there's a horn, and there's not much inside this panel besides a PLC to run this logic, a couple of relays, terminal strip, and then the Johnson Controls has their panel right underneath us. We have our converters for the BMS up in here as well. Any other questions while we're up here? Okay. That green valve that is between the chill water piping and right before the meter, that is a fusible link firematic valve. So if you look at it,
from the damper side and look this way, you'll see a brass arm. You see that brass lever up there? That is spring-loaded and will slam shut. If you look real close, you'll see that arm is connected to a linkage. It's two pieces of tin that have been soldered together, and it holds that valve open. If that temperature gets to 165 degrees, hot enough to melt that solder, assuming that there's a fire someplace in this room, then the solder will melt, valve will slam shut, and if that fire was related to the oil, we're not pumping more oil into the system. And, lessening the damage of that fire. The worst thing for any fire, whether it's electrical or oil-based, is to stop the flow. Shut the electrical off, stop the flow of oil, stop feeding into that fire. So that's what that valve does. And the next one is the fuel oil meter. So the boiler on the other side has 2 meters, supplied and controlled and monitored all by Johnson Controls, but this one only has 1 meter. The reason for the difference is every drop of oil, for the most part, that goes through that meter is going to get burned by the generators. The boilers are continuous flow. So you might have 1,000 gallons go up to the boilers, but you're probably going to have 950 of that coming back. It's boiler consumption there would be the difference between the 2 meters. Here, it's just going to be a running tally. The only way you get oil to count on that meter that doesn't get burned by the generator is if the tank is overflowing back to this. If the only way out of this tank is into the generator by means of a hand pump, which that one has, or out this overflow. That's the only way oil can leave this without something breaking and busting and blowing apart. So that would be the only way to increase the flow count on that meter without, extraneous means. So just to kind of beat it in, like you were saying, unless anyone else has any questions up here, kind of want to just walk down as we make our way outside. Look at all of the valves that would need to be changed to switch between the tanks. So just one more time, we're looking at this valve, which is all just a 3-way valve. They've got the standard locks like many ball valves, and then it would just be switching it in this direction. For fuel oil tank number 2, fuel oil tank number 1. Similarly, this valve back here, the overflow is getting kicked out the back. Where that one gets kicked off the top, this one gets kicked off the back, and there's similarly a 3-way valve that will get switched. And it is also, again, labeled to fuel oil tank 1, fuel oil tank 2. So same 3-way valve, swinging it in both directions. So 1 valve, 2 valve, and 2 valves in the boiler room. So a total of 4 valves would need to get changed in addition to that switch. Which I guess we could walk over and take a look at those valves, unless you guys got any questions over here. So this double wall piping is the existing original piping, which, just to refresh your memory, is this outer pipe is just simply containment for the inner, or for the supply and the return for the old system. So if these pipes were to ever leak, God forbid, it would get trapped as it goes through common areas. Once we leave in mechanical spaces, it's good to go. The new piping was just never designed to be, it was just not specified to be like that. So from this point forward was
changed as part of the new construction. So you can see the fuel oil return was, we have a three-way valve. So just like the two overflows, we have this three-way valve as well that would need to be changed. So I was a little bit wrong. I was thinking up there. So it's three valves, three-way valves that would need to get changed to switch from one system to the other. The two overflows on each day tank, and this one here. So this is going to the old tank, and right now it's going to the new tank. These handles all have a little flow arrow on them. Right now it's showing like this, so the alternate would be to flip it like that. It would be this kind of rotation. Those smaller valves should also still have that same sticker. I forgot to point that out. So if we follow the path of oil quickly, if we're talking about system number one, we come up from the pumps, we hit the valve that's currently closed right now because that is the system's not operational, and then we come into the common header and we either send it to the day tanks or we send it to the generator, send it to the boilers. Goes through the loop, goes through the supply meter, then hits over to a back pressure regulator, which keeps some pressure in that system, and it comes back, goes through the return meter, and then back from the system. Up in the way ceiling is what's called a vacuum breaker. We put that on the return line so that the line can drain. So say we're running the pump, everything's all full of oil, supply's full of oil, return's full of oil. Great. We stop the pump. That means we're no longer sending oil up to the piping up here. But gravity is going to do what gravity does and pull the oil down from the system up here. To allow gravity to do what it wants to do and not suck the entire system dry, there's a vacuum breaker up there. So that's basically just if you look at it this way, it's just a round hole. It's got a ball in there, a stainless steel ball, and it's got a spring. So that spring presses that ball up and keeps it there. Especially when the pump is on, it just pushes that ball even harder in and seals it. But when the oil drains and tries to suck in air, it will drop that ball and allow air to come into the pipe and let the oil drain down. And then we have it, because right now this pipe right here is empty. I could take this union and nothing's going to come out because the system's not on. We want that. That's good. It drains because that valve allows air to suck in. Looking at the brown valve up there is the back pressure regulating valve. That just maintains a set pressure in the piping up here so that it forces oil towards the boiler. There's an adjustment knob on the top and a pressure gauge for reference behind it. You don't need much, maybe, I believe it's set for about 15 or 20 psi. So you can see the older looking one is the existing, the fresh and clean looking one is the newer one. Really essentially the same thing that you guys had before. You have a very, very loud horn with a strobe, test button for the strobe, reset button. The reset button is only going to ever do the horn. If it's in alarm, the light's always going to flash. So this horn is part of the tank system, not part of the pumping system. Once we get out here, we kind of got to look at things independently. between the tank system and the pump system. Tank system is really just monitoring the tank itself and any leaks that are out here, outside stuff. The tank system's taking care of that. So this is for the guy filling. The tank gets to 90% full, then this will start to go off and it will be loud. And obviously the tank driver, the pump driver is going to hit silence on this thing. Great, that happens. What if he says, "Oh, I only got 1,000 gallons left. Let me keep going. Oh, I only got 2,000 gallons. Let me just finish my load." He keeps pumping. 95%. Now it's too much. Goes off again, and he's not going to be able to silence it. So it's kind of like that little bit of a fail-safe. Also, at 95%, there is a solenoid valve down there behind the system. That solenoid valve will slam shut on you as well.
The other one might be open.
The other one might be open?
Both locked?
Yeah, both locked. But if you have a key, great. If not, no big deal. Inside, you get another PLC readout. Tells you what the percentage of the tank is, whether it's 50%, 90%, whatever. But the big thing is there's two buttons. Start, I believe it says start fill, stop fill, or open and close. Those buttons are for that solenoid valve. So on your system, you got a little bit of an upgrade where it's, so we come up to that 90%. The truck driver will hit reset here, make his alarm go away. But then he will also have to hit open the solenoid valve. And then keep going, and then it's going to bang him and lock him out again. First thing, I mean, even if it's at 50%, 40%, that valve is normally closed. It normally seats itself down and closes. So if somebody were to just come and try and either, whether it's malicious or something, like they want to pump water in or do something, say they break this lock, it ain't going to go anywhere. It's just going to hit that valve and stop. You got to open this panel and hit open, and then the truck driver will be allowed to fill. So it's just a little bit of like positive reinsurance that the truck driver is not going to overfill the tank. We're doing everything we can to stop the truck driver from overfilling the tank. Not only
Is that only on this one though, not on this one?
no, same.
Both the
Same.
I know it.
So when we get to the other side, you'll see two solenoid valves.
I don't remember the last time opening it for him. So,
You might just
Yeah, I usually,
push the
Yeah,
button.
You push the button?
yeah.
Yeah. Also, when we get up there, I'll point it out again.
But
But
of the big tanks.
not only are there these electronic stops, there is also a physical stop as well. So there's sitting on the fill pipe going into the tank is a float. When that float lifts up, it closes a valve. And now there's another valve in there that's closed if it's over full. So it's really, there's no way this driver is going to overflow this tank. Whether it's this solenoid valve slamming shut on him or that physical valve is going to close on him eventually. And that's just, it's a float and a lever, and it just closes itself. I'll point that piece out when we get to the top of the tank. If it's a situation like we were talking about before, valves were misaligned and we're pumping from one tank to another, this is still going to go off and be a loud son of a bitch. But that's kind of a good thing. If this is going off and it's a normal Tuesday afternoon, look into it right away. There could be a problem, especially if that pump is running. You know what I mean? So this thing will kill your ears. It's loud. You'll know. But right next to it, on both sides, this apparatus here is what I was just talking about. This is the piece that has the float on it, because this is your fill line, fuel oil fill that's coming from those fill stations there. So this is the piece that has that physical float in the tank that's going to lift and shut it off. You just pointed out the stick gauge port, so you can manually see what the level of the tank is. Over here looks pretty identical to the other system with slight changes. So this is a tank within a tank. Much like your original day tank upstairs. So what we're actually stepping on is an outer containment for the main tank that's inside. So we have to vent that middle section. That is what these are here for on the PVC edge. In this, we're venting the outer containment, just allowing any air from building up inside there. This wire coming out, that is your leak sensor if the inner tank were to fail. Same position as the old one, just on this one. So again, this is all being monitored by the same tank system. All these sensors out here are the tank system sensors. A little difference you'll see here is we made a little design upgrade and gave you a box. So this is for the filtration system, which I'll talk about in a minute. This is your suction. Your suction for the filtration system comes in from here. Being a sump in itself, there is a leak sensor. This, I wrote it in big old letters on the underside of this. The wonderful engineers are calling this sump number 1, which is sensor number 2. So that's what it's going to say. It's on the tank panel there. If this sensor were to go off, it's going to say sump 1, sensor 2. It's going to flash alternating sump 1, sensor 2. So that's what I wrote here. It's going to be that leak sensor there. And if this were to fill up with oil, one easy way to get rid of it is there's a plug. And that's just going to drop it into the main tank. You pull that plug out, and any oil that's sitting on there will just drain it to the tank.
Where's sensor 1?
Sensor 1 is that one.
Oh, right.
So sensor 1, sensor 2, sensor 3, sensor 4.
All right.
These are essentially relief valves, little burp relief valves. So if the tank were ever to get pressurized, these would have a spring and lift oil and let oil out so it doesn't blow up. This is another vent, obviously a manhole. Keep coming. So the first sump was for the filtration suction. This one is for the filtration discharge, which I mentioned that was a slight upgrade from before because the other tank has them both coming in and out of the same box. So same situation, we have sump number 2, sensor 3 written on it, another leak sensor. So this is an upgrade because we like to have the suction of the filtration as far away from the discharge of the filtration as possible. That kind of creates a guarantee in there that we're not just filtering the same oil over and over again. Because it's a big, long tank, we want to be able to make sure that we're getting every drop of oil in that tank, or as much as possible. So, God forbid this union leak or something, we'll trip that alarm.
The painter.
I don't paint things. I just tuck. Let's keep going on the small boxes before we get into the big stuff, the big juicy stuff. So the last box here, which is sump number 3, sensor 4, is these are the bigger one is the main fuel oil return. The smaller one is your overflow from the day tanks. So those got ran down all independent, and we're monitoring that for leak. And again, there's a plug to drain it if so desired. This is your level gauge. This actually has 2 floats that ride up and down on that stainless steel shaft that's sticking up. We monitor those 2 for the position, and that relays and translates into inches which then translates into gallons. So that's what the tank gauge read. This is how we read the actual number of gallons, 10,000, what have you, and then we send that out to the BMS locally. This is what's also driving your 90%, 95% alarms. This probe right here. If you ever do need to take it out, it is kind of like a spin-off quick disconnect. Always turn off the power before actually spinning that off and disconnecting it. The second float that's riding on there is for water. So it has the same float, except the water one has a couple washers attached to it, which weighs it down, which means it's perfectly weighted to sink in oil, because oil floats on top of water. It's going to sink in oil but float on water. So it's sitting at the bottom waiting for water to accumulate and then lift that up. If that float really moves, I think like a half an inch, starts to set off an alarm and says, hey, starting to get water build up in your tank. Where the other one will just be floating on top of the oil wherever that goes. So for the big one. Yes.
I got a 2:30 meeting.
Okay.
But I'm here, so if you need me for anything, call me, okay?
Okay.
Thanks.
So part of everything was again a little bit of an upgrade. This little box for the fuel pump system. Part of this engineering was to replace the entire pump set unit on that one, on the existing system, because since we're so close to the lovely Atlantic Ocean, they rusted out pretty quick from the salt air. So this box is not designed to be waterproof, but just designed to stop all the wind-driven salt air from really getting on it. Identical in the pieces and components to what's on that tank. So by you guys, we have on the PVC, that's the foot valve extractor, which then is the suction line of the pump, which goes all the way down to almost the bottom of the tank. Actually, let me hop in there. So these are just screwed on by hand, just to stop dust and dirt and grit from getting and sitting on the top of it. That bar right there, this high-tech piece of equipment has a slot cut into it. Grabs that slot.
Make a holder.
You could. I mean, we were doing it with a pipe wrench. Grabbing then this with the pipe wrench. You're not going to do it by hand. Absolutely not. It's pipe wrench. We were grabbing it with a pipe wrench.
Make a hole in piece of metal stick.
Yeah. So then spinning that off, and attached to this brass piece is, how tall is this tank? Call it 8 feet. Is probably like a 7.5 foot pipe to it. So as you pull that up, it's going to have just a 7.5 foot straight piece of pipe, but then it's going to have another brass fitting on the bottom, which is essentially a check valve. Check valve with a screen. We call it a foot valve. So each one of these lines has a foot valve with a screen. That screen can get dirty. This is why we have all these means and allowances to pull that pipe out. If it was just a straight piece of pipe, we wouldn't need all this. But that's a service item. Say if you're having flow issues, there's no real strainer on these pumps. It's that the strainer is that screen that's on the bottom. So if you're having flow issues, instead of opening and cleaning a strainer, you would open and pull that out and clean that screen.
Is this a solenoid valve?
That is a flow switch.
Close.
So I mean, this doesn't need to be. I'll say here. There's two rubber gaskets.
O-rings.
O-rings, rubber gaskets. Yeah. Very important that those are in good condition, because they seal two ways. They seal really from air getting in, because it's the suction side of the pump. That's what you're concerned about, is air getting in. Not necessarily oil getting out, but it seals against air getting in. So the two ways that air can get into that is either from the outside of the tank and down the top, or the top of the tank is always going to be filled with air, right? Because we never fill it past 90%. So then coming in from the bottom. So there's two O-rings in there that when you pull it, you got to make sure those are good and the seats are clean. Otherwise, you'll run this pump all day long and it'll just never get a suction and you'll never get flow out of it. This doesn't need to be tight at all, just to stop dirt and debris. We have a sensor here for vacuum. That's going to be a digital readout on the screen, just gives us a vacuum pressure. And then a very similar readout on the pressure gauge is just pressure, which will also read down on the pump down there. Flow switch is our positive proof of flow and our standby system. So when everything is aligned for this tank to be in operation, which it currently is, one of these pumps will run on a call. Say boilers come on, pump number 1 comes on. On a good day, this pump is going to run until that call for oil goes away. Once that call for oil goes away, pump stops, and then once the generator or the boiler kicks on again, the other pump. So it alternates, not on a time, not on a schedule. It operates and alternates on a new demand for oil. The automatic standby start. So say boilers call for oil, pump number 1 comes on, runs great. 5 hours later, we lose flow. For some reason, I don't know, overloads, pump fails, dirty strainer, any number of reasons we lose flow. For 30 seconds, I believe, is the time delay. Start the other pump. Shut this one down, start the other pump. So that would be an alarm saying, hey, pump number 1 lost flow, but all good, pump number 2's got it. If then, 30 seconds later, pump number 2 still has not satisfied this flow switch, you're going to get a second alarm that says, whoa, both pumps now have lost flow and I'm dead in the water. And now that's going to take somebody to come really and switch over to that system, and then you can diagnose, was it a flow switch issue? Are the pumps bad? Any number of things.